Coming up. Should be coming up. So while you wait, do you all have the access to the repo? There is a repo link which has the reference.
But it's local, so you don't need to use platform for this.
I don't have the access to the repo. You don't have access to it? There was a repo link I posted, right? It's public, yeah. So just go to that repo, like keep that handy. So what you will do is you use that as a reference. You won't really like just copy paste it and write a whole code. But that is there for reference, so you know like what we're actually building. I'll keep motivating the ideas on like what we are actually building, but that you can use as a reference whenever you're stuck. So every module there, sorry. Yes, like before we start, like, I'll just talk about setup a bit more. So you need an OpenAI key, of course, and you need a Composio API key as well. If you don't have a Composio API key, you can sign up for an account at app.composio.dev. So it's app.composio.dev. And after you sign in, I'll just show you how it looks like. So 1 second. Hello.
You cannot see that. I just write on a paper. I just write into like name definition.
You can sign in with Google or GitHub at app.composio.dev.
That's what we have.
Yeah. After you signed in, you'll find your name here behind this, whatever this is. So if you click here on the bottom left, you'll find an option for an API key. And that's where you get an API key. Can you all see this, by the way? Like, if for the people in the back, you can maybe look at the other screen.
No, it's not switching the screen.
Ah, okay. Okay.
There was that same screen use करना पड़ेगा.
Oh no, but I can maybe share the whole thing as well. Let me see if I can do that.
Sorry for password. So you can ask this password down. This is the password. Everyone is back.
Composio.dev.
Get an API key for demonstration.
Okay. It's only for
So once you set it up, I'll tell you why we need this, like what the benefit of having an API key is. So we'll go through all of that step by step. So I think this is for initial setup so that everything goes smoothly. But then we'll see why an API key is needed, like what is the purpose of Composio, when to use it, when not to use it. All of this will come as we explore the workshop. Yeah. Oh no, you did the wrong one. This is not in Composio API. This is
No. I'm talking about OpenAPI, the one the posted on that link GitHub.
let me just double check 1 second. I'll just update it 1 second.
So, we go to the platform and you sign up. Yeah, just the API.
Hello, hey Janav, nice to see you.
Can Viraj or one of you respond to this comment? They're asking for the Git repo link.
Oh, okay, sure.
Yeah.
Is the key working for anyone? Like, you still see the error? I think the key is right. But far as I see. Can you show me how you're exporting the key?
Not easy and then same code.
Yeah.
Provide, you can use that URL for agents.
Okay, then that looks
If
good.
you want to build and follow through the agents, you can use this.
Yeah, we can also use slot, like you can choose the model you want to use, like you can just use title there.
Yeah, but this works with your OpenAI, but there are different providers you can switch.
That should be fine, don't worry. Yeah? Yeah, I put it on the mic now. Perfect. Let's see if it doesn't work for you again, I'll just switch the key as well, okay? Yeah.
I don't get any
Let me see. Show me what
API key not found here, right?
For this you need a Composio API case. I'll just quickly talk about the setup. So I think let's begin. Like I'll start with introducing what this workshop is about, what we will cover, and what setup you need to do. Right? There my case was. Okay, perfect. So I think before we start with the workshop, what you need to do is like set up the OpenAI key as I already told you, and also export the Composio API key. So everybody has access to the GitHub repo that I showed you earlier, right? So I would like you to just open this repo right now in whatever your favorite IDE is. Cursor, VS Code, doesn't matter. So open this specific repo there. I'll just zoom in a bit more for people in the back to be able to see it. Can people see it? Like for people in the back, can you see the screen there? Not visible? Is it not visible? Achhe se kya? Like should I zoom in? We're fixing it. Okay. But anyway, I think what I want you to do is like just open the repo I sent earlier on your laptops, and then what you need to do is set up two different things. So whatever your terminal is, you can either do using an environment file, or you can export OpenAI API key and Composio API key, because these are two keys we'll use throughout the workshop. That's the only setup you need, right? And then we'll go through step by step. I'll explain for each module what setup you need to do as well. It's very simple. But before that, let me motivate like what the idea of the workshop is, why we are doing an AI agents workshop, what will be covered in this whole workshop, and how the flow will look like. So I think after the setup is done, we'll talk about mostly building a coding agent from end to end. Sorry? All good, right? Okay, perfect. So the idea that I had was like, okay, we'll first see what a production AI agent looks like. So we'll use, let's say, either Cursor or GitHub Copilot, whatever you use personally. So I will show you how this looks like for people who are not familiar with it. How many people here know Cursor or have used Cursor in the past? Okay, so I think all of you have. So Cursor is basically a skill on top of VS Code, which now has like a AI agents. Have you used VS Code in the past? Have you seen GitHub Copilot being used? So Cursor is similar to that. Like in a way, it helps you code different files. So what I want to do is I'll first show you what Cursor is. We'll run a very quick application through Cursor. So maybe I can build a portfolio website very quickly. I don't know any front-end development myself, but I can do it using Cursor, for example. So maybe I'll just randomly ask for ideas. Do you have any idea that you want to implement? Any random app or website that you want to build? Anyone with any ideas? We'll just see how it looks like in execution.
Travel app.
A travel app, okay, let's build a travel app. Let's build an app which can recommend itineraries for you based on where you want to go, right? So like that's all a simple idea. So how Cursor usually works is if I come here, I can just, let's say, let me remove all of these here. I just say, build me a travel app that can recommend itineraries based on the country I wanna go to. Make a website.
Jayesh,
Yep.
that's not visible.
This is not visible?
On chat, on the HTML it's not visible.
That's interesting. 1 second. Yeah. Okay. Cool.
I'll just.
Display capture, but like it's not. Can you go back? I can switch to display capture again.
I don't think it's a display capture issue.
Because I changed it away, but never mind. So it doesn't show. Now it shows, right? Can you see it now?
No.
One second. I think I'll just restart the stream. It'll work. Pretty sure.
Yes.
It works now, right?
Bro, I have a better option for
No,
that.
no,
Wait.
no. Chilla. No, I think वो चल गया अभी. ये वर्स्ट केस कर लेंगे.
Yeah, it's visible.
Hello. Yeah, thanks. Let's go. हो गया. Yeah, never mind.
Wait अगर नहीं भी हो रहा, I think उसमें और भी issues आएंगे. हम just
बना के रख लेते हैं. आगे जो जरूरत पड़ी तो कर
इसलिए
लेंगे.
मैं बोल रहा हूँ.
Correct. It's fine.
Join now. Share. तेरा पूरा विंडो शेयर कर रहा हूँ, ठीक है?
Entire screen ही कर दो.
ठीक है, entire screen
Best.
कर रहा हूँ,
हाँ.
सबकी check. ठीक है, wait.
ठीक है. Best है.
इसको और जगह पर.
Sorry for the disturbance.
Yeah, I can see the whole thing right now, right? Okay, for people who have just joined, hello, hi. No problem. Okay, so like I was just like trying to motivate like the idea behind the workshop and why we are doing AI agents workshop in the first place. Hello, yeah, go on please.
You
Sorry.
also have to introduce yourself.
Oh yeah, true. Take a seat, Ronald. Any more? Okay, perfect. Never mind. I think we can just start. Never mind. So yeah, I'm Jayesh. I work at Composio as an AI engineer, and like most of my work in the past has been with building AI agents as well. So we're building a host of AI agents internally for our own purposes. And what we've learned throughout like this month and two of building AI agents is a lot of tips which I want to give to you today. So what we'll do today is we'll do a very miniature version of an AI agent system in production. So we'll walk through all the pitfalls that you see from a simple toy example all the way to an advanced example. And to motivate all of that, we'll first look at a production AI system in itself. For example, the cursor system which I was showing you earlier. So we have all used cursor or a version of it in the past. What we'll do today is try to build something like this from scratch. So you'll see what exactly goes behind a system like this and what are challenges which come up when you try building the system yourself, right? So I think the first step which we do is, like I'll just show you how this works for people who are not aware of how this works. So I give a prompt which is as simple as build me a travel app that can recommend itineraries based on the country I want to go to, make a website, for example, right? So it's very simple. I'll come here and I'll choose the right model. I love Sonnet 4, of course. So you can just choose whatever you want. I think Gemini 2.5 Pro is also really nice, but otherwise Sonnet is good enough for most stuff. And I press enter. So now what you will see is this model will now take this single prompt and start thinking about how to build a website like this. And if you look at the code here, it will soon show you how it creates new files, tries to figure out, it makes a plan first. So the idea behind this is that it's not just a simple LLM call. A lot goes behind it. Like there's some planning involved, like what files to create, what are the steps to accomplish. And then there's also some actions, like it is writing a file now. It's trying to generate the code first, and then it will write this to a file in your local machine as well. So this whole system works on multiple tools. So planning is there, editing is there, file tools is there. Sometimes it uses the web search as well. So if you ask it to use, let's say, latest version of a library, it will try to search for that library online, get the documentation, read the docs online, and then implement that based on whatever the docs say. So it's a complex system, right? Like it uses multiple tools and it performs a action which is super useful, right? So I'll just stop this for now, just for the sake of demonstration. So what we've seen so far is a complex system which does file creation and everything else. So now let's try building something that's in the ourselves right now, right? So the flow of the workshop will be like this. I'll start with a very simple toy example. We'll implement this together. We'll run this together. The code already exists here. I think the code for the entire workshop is here. But what we will do is we'll do it ourselves step by step. So for the first module itself, you don't have to write any code. I'll just walk you through what an AI agent actually is. I'll make you like understand what the agent loop is like, what is the basics of an agent, and we'll understand that through this example. And after that, we'll start coding ourselves. So like from the module number 2 itself, we'll start implementing our own agent systems. We'll have some variations. You can build your own side projects with it, for example. And then we'll slowly get to a point where you'll have a multi-agent system, which is like properly traced, so you know how problems are arising, when to solve it. We'll have observability as well. So all of those things will come into the picture as well, step by step. 1 second, let me adjust the mic. Okay, perfect. Yeah, so like that's the flow. We'll start from a toy example. We'll keep adding stuff. We'll keep motivating why a new requirement is there. For example, multi-agents, why are multi-agents required? When to use multi-agents, when not to use multi-agent systems. That is one of the points. When to use tracing, how to trace your agents, because that helps you observe how your agent works and also help you debug problems. And then we'll come into state management. What exactly is state management? How do you track variables across agentic systems? And how do you transfer context, all those things? And finally, we'll see how evaluation happens, because evaluation is also a very important part of it. Because once you start building large agent systems, you need to make sure that whatever prompts you change, do they actually have some good effect or are they regressing your system? So all of those things will motivate step by step. You'll see the need of why you need, let's say, evaluation, why you need multi-agent systems, why you need state management, all that. Okay, so with that stage set, any questions so far? Any lack of clarity on what we are doing, why we are doing it? All clear on what's going on? Okay, perfect. So now, like I showed you a very simple working of a cursor agent. Now let me start with the toy example. So with the toy example, my motivation is that I want to make you understand what exactly an agent is from the first principles. So we'll not use any framework right now. We'll not use any agent frameworks. We'll just think from the first principles what an agent looks like what exactly is an agent in the first place. So for that, let me use the whiteboard a bit. Okay, 1 second. Let me put this down. I hope everybody can see the screen at least. Cool. I'll just need a pen. 1 second. Let me take the green pen. Marker, yeah, exactly. Okay, so an agent from its very basic principles. Sorry.
Point the camera.
Oh yeah. I think the camera is looking here. Maybe I'll just enlarge the camera a bit for people to see. Yeah, 1 second. No? Better? It'll take some while to reflect. Huh. But anyways, I think I'll just motivate what an agent is from first principles. So if you're all familiar with how LLMs work and what LLMs are, I'll just remove this here. All right, so LLMs, we all know how they work. We send a request, you get a request back. It's all text-based. You send a text, get a text back. But then like what we want to do is like how to make this act on your behalf, how to make API calls, how to perform some actions. That's what an agent is, right? So ultimately what you have is an LLM which you're already familiar with. And then you have some tools. And all the tools are simple functions. So this could be like a Python function you write. For example, book a flight could be a Python function, which ultimately calls, let's say, the make my trip API or whatever other API you want. Right? So a set of functions which are performing the exact actions you want. So this could be, let's say, book a flight, write to an Excel sheet, or whatever different actions you can think of. And then there's an LLM. So all you do with an agent is a combination of these two things. So what an agent does is that, let's say you send a first request to an LLM saying that, okay, you have access to these tools. You give it a list of tools. Okay, you can book a flight, you can write to Excel, you can do X, Y, Z, whatever. And then you tell the LLM, okay, give it some task. Okay, you can tell it, okay, I want to plan a trip with budget and with some itinerary as well. So what this LLM will then do is it will tell you that, okay, to do this, I need to call the book a flight function, because it already knows that it has access to a book a flight function. So it will tell you, because it will only output text. Remember, it's only text in, text out. It will tell you that, okay, I need to call this particular function with parameters, let's say Bangalore and whatever. So it will give you what parameters to use and what function to call. And now the system that you build needs to take these parameters and needs to call this function with these parameters. And whatever result you get out of it, for example, booking successful or whatever other response you get from it, we feed that back into the LLM. So LLM knows what happened after the execution of this specific function. So what you do is you ask the LLM, give it a task, give it a situation. It gives you a response back telling call this specific function with these parameters. You call the function with your own code, whichever you write. And then after the response is received, you send it back to the LLM, say, okay, I called this function. This was the response. What next? So it will give you a next step as well. So like this is the loop which happens. And this is called the agentic loop. So you must have heard this term around quite a while. So essentially this is the loop, a loop where you call the LLM first with a task. LLM sends you a response back, and then you send the response back to an LLM. And you do this repeatedly until there's no more tool calls happening. So when an LLM just says there's no more tool calls, this is the final answer, that's when you stop. So that's a very basic agentic loop. Any questions around how an agent works? Right? So this is entirely what an LLM is. Like all the Hyperon agents does this, an LLM with some tools and a loop which runs. So any framework you use, let's say OpenAI Agents SDK, LangGraph, whatever framework you want to use to build agents, they will have this loop in the background. So now I want you to look into this first example, the toy example. So once this is set, I think this will make more sense, the code which I'm going to show you now. So let me just, 1 second. Okay, let me remove this. Never mind. Okay, perfect. So if you look at the code here, what we do is like I have a bunch of functions. So we talked about the tools that an LLM has access to in an agent. So here you have, let's say, a Python code runner. So this will just run the Python code. Don't have to worry about the implementation right now. We can just reuse this Python function across all of our different modules. But you have a run Python code function, because remember we're making a coding agent tool, right? Coding agent. And it will have access to, let's say, file tools to write certain files to it, or an access to, let's say, a run Python code to run that code itself. So you can also come up with your own ideas. Let's say if you want to build a coding agent, what tools do you really need? You have to think about it yourself. So before an agent, so whenever people are building an agent, I think personally, the first step that I do is think about what are the tools I need. Because ultimately, as you've seen, the main majority of the work here is done by the tools itself. So if you master the tools, if you like have really robust, really nice tools which can perform a lot of actions, then you have a great agentic system in place. Right? So this is the heart of an agentic system, building great tools. Right? So what you have to do is like the first step to building a coding agent will be thinking about, okay, what tools do I need? So let's make this as an open question. So we're building a coding agent, we know that for sure. What tools can you think of that an agent like this would need access to? And you can use the example we saw earlier, like we looked at the cursor example, use that as motivation and try to figure out, okay, what tools would such a system actually have in the background? Can we have some like random guesses here? Like I think it's pretty apparent from what we've seen so far. So let's say one could be the file tools, correct? Like writing to a file, reading from a file, editing a file. What other tools can you imagine that an agent like this would have? Compiler is right. Okay, perfect. What else? Code search, yeah, exactly. Code search is very important because you want to know, like, if you want to make edits to an existing code base, you need to perform a search over whatever code exists. You need to like have different pattern searching, embedding search, whatever kind of search you have. That is true. Sorry. Shell command, exactly, because you must have seen when you run commands through cursor also executes terminal commands, right? So it also has the terminal shell command as well. Perfect. What else? Don't we need?
Infrastructure to run this agent?
Yeah, of course, it runs on your local system for now. So like whatever you build, the agent that you build is a Python file, right? It will run in your local system itself. So the tools that you define, let's say shell tool that you define, you will just call, let's say, subprocess.command, something like that. So whatever you define will be run locally for now. That's the infra that you have, right? So you have like a shell command true, you have, let's say, code searching, you have file tools, you have compiler, you have, let's say, style checker, all of these different tools that you have, right? So, and for now, we can also actually just ask cursor itself, right? So let's do an experiment here. I can just call cursor and I can just tell, okay, what tools do you have access to, right? So like this is something that can also be, I'll remove any context from here. This is a great way of knowing if what we were thinking about was right. I think what we missed here is search the web tool as well, because there's also search the web. And in addition to that, it's like GitHub tools as well. So like a bunch of tools that you can think of that a coding agent might have, right? So as you can see, it says I can run terminal commands, I can do web searching, I can delete files, apply edits, read files, file search, as you said, directory listing, semantic search, text search. So all these are tools that this cursor agent has by itself. Of course, the LLM itself doesn't know how these are implemented. It only knows the name of these tools. So you can't ask, okay, what does the tool definition look like? But that is something we'll also come into knowledge as we move further with this thing. So like all the LLM knows is that it has access to this n number of tools. These are the names. This is the request schema for them. This is description. That's all it knows. And how you define the tools is up to you. Right? That is the idea. Okay, so with all that context, I think now we can go back to our toy example. 1 second, I think it's messed up. Yeah, okay, perfect. So
Basically, these tools are predefined or it decides by itself.
sorry, say again.
These tools are defined by default, like agent will look at these tools.
No, it's all up to you. So if you look into this file, it's a self-contained file. Whatever is there is written by us directly. So you can define your own Python functions. It doesn't matter what those functions are, what the signature of the function is. It is entirely up to you. There is no set of tools that you define, that you reference from. You can write your own functions. For example, if you, okay, everything will be clear if you look at the code right now. Let's just walk through it once. So you can see there's one function called run Python code. Right? If you look at line number 35, this is something that we have defined ourselves right now in code, right? and we will give this as an available tool to the LLM, right? So this is like our function that we define. This can be anything you want. And usually what you do as best practice is that you add some doc strings to it, and this doc string is usually picked up by the LLM to know what this function will do, essentially, right? So like this is one function, and then I have a create coding agent function here, and this is what actually will define this whole system here. So whatever you see here, and if you look closely, what I have is a bunch of file tools as well, because you already know we need like read, edit, whatever that is. So instead of implementing it yourself, this is where Composio comes in the picture. So what you can do is that you can just use Composio's managed tools. So Composio as a company, what it does is it provides you managed toolkits for n number of apps. For example, if you want to perform operations on, let's say, Google Sheets or Excel or whatever other application, instead of writing this function yourself, like implementing the Python function yourself, you can just use something like this. So for example, I wanted to get a create file, edit file, list files tool. Instead of writing this Python function myself, I can just call Composio, toolset.get tools, and I can mention what actions I need. And the implementation of this action is with Composio itself. So Composio writes and implements this and maintains these tools for yourself. That is the idea of Composio, right? And this exists across n number of apps, so whatever app you need. And that's why we need the Composio API key to make this work, right? So what we've done is we've defined run Python code before, right? And we also have some file tools from Composio. And now what we have to do is you have to give this all as a context to our LLM, so it knows what tools it has access to, right? So if you scroll further down, you will see I've defined a JSON file here. So usually how you tell the LLM what files it has access to is through this JSON file. Because if you think about it, what way, like if you just think from first principles, right? How will you tell this LLM what tools it has access to? What mechanism do you have to tell the LLM that you have access to such and such tool? Through text, right? Because it's a language model. So all you do is just send it a text. And we do it in the form of a JSON. So OpenAI has this standard, which is what you see here. So you define a type, you define what function it is, you define the name of the function, description of the function, and what parameters to pass, right? So this JSON is what you pass to an LLM to tell the LLM that you have access to this tool and how you run it, right? So once the LLM sees this, it knows how to call this function by providing the right parameters. Correct. Yeah. It will be passed in every prompt, every request you send to the LLM. So it will be appended to your prompt. Yeah, that is the idea. So I'll show you now. Let's get to that part quickly. So what you see now is there's system instructions. This is your normal prompt on like what to do. It says, okay, you are a helpful coding agent. You can perform these operations, whatnot. Your normal system prompt, whatever you have, right? And in addition to this, when you actually call it, let's say you pass the tools like, okay, let me just show you this part here. So let's get to the OpenAI's chat completions API. Has anyone here used OpenAI's chat completions API in the past, right? So if you see that, like you'll see you have an option of tools here. So in the background, you're right, like whatever JSONs you give is part of the prompt itself. As I said, like LLMs is just a text in, text out model, right? So whatever you think of, any JSON, whatever, that is passed as text to the model, and that is the given context. And to add to that, LLM is stateless, right? Whatever request you make, every request you make needs to have the whole context that you want to like convey to the model. It's not like you can just send one request and that will be, because LLM doesn't hold any state. When you make an API call to the LLM, it doesn't know XYZ, like you have to give the whole prompt. So everything that you pass here will be ultimately converted to a text format, which is passed to the LLM in the background. So what we do is like we take the tools, right, and we take the messages, and we do an OpenAI call here. So we use OpenAI's client. So you first define an OpenAI client. I can show you what it looks like. So you define, let's say, one second, an OpenAI client. This is where the OpenAI key comes into the picture, right? So this is the client. You define it like this. You use the OpenAI's Python SDK. You define a client, you pass in your OpenAI key, which we have done through the environment variable. And after you define this client, you can then use this client here in the call that we make. So this is the API, client.chat.completions.create. You pass in the model that you want. We're using GPT 4.1 because that's the new standard general model. We pass the messages. Messages is just a list of all the messages you want to pass to it. So if I go here, I can show you what it looks like. So messages is, like we usually have two different types of messages, so three different messages. The first is system message, which holds the system instructions. This is usually at the top of the message hierarchy. So like you send that first to the model. And this is what sets the stage for the model. Okay, like for example, giving the model a persona, giving some system instructions on how to do what to do. All of that is part of the system messages. And that is how you mention it. You mention a role and it's a system role. Then you have a user message, this is a message that a user sends on your behalf. So when you define these things, this is how you put it. So whatever request you have here, let's say you'll send, I need to create a Python function which calculates the factorial of a number. That will be part of the user request here. So this is the format that you pass into it. Again, this is an OpenAI standard, which is now the standard across the industry. So you define a JSON object like this, you pass a role and you pass a content to it, right? So you define the message objects like that. Once you have the messages, once you have the tools, and I said tools will be in the JSON format as I showed you earlier, you can then make the API call to client dot, one second, yeah, this is the API call. You make this API call, right? You get a response back, and then the loop starts. You remember the loop I talked about here? So this is the first call you made with the giving the model some tools, giving the model some user prompt, and after that what you do is you take the response and then you check if the response has any tool calls. So the object that you get back from this tool call is a chat completions response. So if you look at this is a chat completion object, and this object has a choices property. Usually you get like multiple choices sometimes. If you use ChatGPT, you might see when you use ChatGPT, it gives you sometimes multiple choices on what to use. So in the API also you get sometimes multiple choices. So we'll just take the choice 0, like the first choice, whatever that is, and we'll take a message from that. So this is what the object looks like. You get a message response, and then you check if the response has any tool calls or not, right? So you check if the response has any tool calls, and once you have that, you can then handle these tool calls yourself. So I would like you to just read through the code once, because this is very crucial to understand. And we won't really use this loop ourselves in the future. We'll just use an agent framework, but you should know how everything works in the background. So this is code you don't have to use daily at well. So like you can just use an agent framework. We'll show that in the next module. But for you to understand what an agent looks like, you need to know what a loop is, how the loop works, what are the different functions of it, all of that shit, right? Okay, cool. So this is what the loop is. Let's quickly look into the loop. But before that, any questions so far? Go on. Yeah, go on. First you and then you.
How does Composio knows that what are tools to provide to the customer? Like there are there are multiple things that the customer might want to do. Like
Correct.
you can't do exhaustive, can't provide exhaustive number of tools
Mm-hmm.
to the customer. So how do you list the number of tools that you can
Okay, so there are two ways to do it. So like if you know what your use case is, we have a use case search API. You can just type your query there, like, I want to do this and this stuff, and then Composio will give you exactly the kind of actions you need to put to your agent. For example, if you look here, if I scroll up a bit more, when I create the agent, you will see I explicitly mention the kind of, one second, sorry. Yeah, so if you look at the code here, I'm explicitly mentioning I need 3 actions. An action is a tool also, it's a different name for a tool. So I'm mentioning I need a file tool create file, I need a file tool edit file, and I need a file tool list files. So you choose yourself what tools you want from Composio.
Yeah, I get that. I said that. I mean, my question is that how do you create these? I mean, these functionalities are being provided with Composio. Right?
Correct.
So how does Composio know that? I mean, there must be some fixed number of use cases that you might be providing for right now,
Mm-hmm.
but the customer might need something else as well.
Yeah, so to answer the question, yes. I wouldn't say fixed number of use cases. I would say we have a fixed number of tools right now.
Yeah.
And yes, exactly. Like as you said, customers might require something else. So there are 2 ways to go about it. You can either raise a request, Composio will like provide you tool for that, or you can write your own
Custom tool.
and then you can inject it into Composio's ecosystem.
Yeah. If you look at the docs, you'll see how to do that. Like you can, within any app, you can add your own custom tool. Yeah, you give first. And then.
I have 2 questions basically. So the part where we are describing our own tool, this
Yeah.
Python executor, the run Python.
Yeah.
So the type is function,
Yeah,
and then there's a function definition.
correct.
So what other values can be in that type field?
Oh, in this one. So like this is,
104 like.
okay, perfect. So what happens here is that when you pass this as an object to OpenAI's API, there can be like a type of message, which is a message and not a function. There could be like a tool call as well. So a tool call result or a function result as well. So this is like just defining that whatever you're sending right now, it's a function definition. So essentially like everything that you send, like whatever messages you have, if you look at the messages about, there's also JSON file here, which is about like, let's just show you, okay, one second. So this is like a message format, right? This is like role and this one. And what you have here is type is function, and I think what you can also have is like a function result as well. So it just serves as a purpose for OpenAI to know that whatever you're providing next is a function definition.
I don't really understand what you meant by like there can be a function result type of a tool as well.
Okay, so
Really catch that.
I think, okay, so what I mean is that in the future it can have, let's say, different types of, so okay, ultimately whatever you pass here goes to the OpenAI API, right? So you can define in the future multiple. For example, if you use real-time API, for example, OpenAI also has a real-time API thing, right? The streaming one, exactly. So that could be a different type of function as well. Just my guess, I'm not super sure, but like the only purpose of this is to make sure that OpenAI in the backend knows that this is a function definition. But in the future, they can add multiple types of things as well. So like I think you can just search for what it exactly has to offer. But that is my idea of how it works, essentially.
And my second question is actually sort of similar, but so the part where we were defining the messages of system and user,
Mhm.
so there were rules.
Correct.
System and user. As an agent, can you come up with extra roles being like in your agent? Like
No,
okay,
not
so
right
those
now.
are-
Yeah, this is a system, there's user, and there's assistant.
and this
Assistant is what the model will send back.
okay.
Yeah, like I think you can, like in the future there might be rules, but I think it doesn't make sense right now to add more roles because it's like a standard across the industry, like system messages, user messages. Yeah, yeah,
Their API is a standard everything.
exactly. So like,
But in one of them is there is that role tool also.
yeah, there's a role to exactly. There's a tool there's a tool called result. So that also comes in the picture. We'll see that later on. But you're right, like there's more like that. You're right. So essentially, like when you're handling this all by yourself, right? When you're like managing the messages yourself, you have to be careful to mention these in the right order. For example, if you look here, I defined a system and defined a user. I can also add another line here, which will be role assistant. So I can also add a AI message myself here. Dummy message, exactly. What AI must represent. Because ultimately, in every call you make, the AI sees this list of messages. So even if the AI did not respond in the past, doesn't matter. You can just inject it yourself. Like assistant said this in the past, whatever. And when you make a tool call, it registers as a role tool or function. I don't remember the exact name. But then after that is done, when you get the tool response, remember I said like once the tool response is back, you send that back to the LLM as well. And that time the role is tool call result. Sorry?
You run it.
Yeah, exactly. So in this loop, so once I'll show it to you right now. Like let's just scroll down a bit more. So look at this. So now the role is tool. See? So like when you execute a tool and you want to append that result back to the conversation, you have to specify it as a role tool. And then you append the content and the tool call ID. So this is what you do. So like the order needs to be very well. So if you're managing the API yourself, you have to make sure the roles are managed very well as well. So like all that is up to you to do. Sorry. One second. So this is the API way of doing things, like everything from scratch, bare bones. Like you're managing the messages array yourself. So you define the roles, you define the messages, and that's how you go about it. But coming back to the loop, I'll just quickly look at the loop again, and then we can actually go to using an agent framework. Yeah, go on.
I had a question.
Yeah, go on.
So this function, that the schema that you are passing,
Yeah.
like in the API,
Yeah.
like in the payload. So this is the so this is a standard across like any API provider like Amazon.
Correct.
OpenAI?
Correct.
This format is standard.
Yeah, this is standard. Like I think the real-time API that OpenAI has, that is a slightly different format, but like more or less is the same. I think
And you internally in Composio also follow the same.
exactly. So like, for example, in a different provider, there might be slightly different JSON. It depends on like, I think Gemini has a different standard because Google doesn't really follow OpenAI standards so much. Like there's a,
If I now switch to Anthropic for
Yeah.
calling an Anthropic
Yeah.
API, can I pass the same payload?
yeah, Anthropic you can probably pass it, yes. But otherwise you have to switch a bit. But at Composio, what we do is like, Composio has different extensions. For example, Composio OpenAI is a package, Composio Gemini is a package, Composio is like has packages for all the providers. So what we do at Composio is when you define these tools, we do the conversion from the function you write to the JSON. So whatever you see here, you never have to write this yourself actually. So in most cases, like even with any agent framework you use, let's say LangGraph or OpenAI Agent SDK, you never get to this stage. All you do is define a Python function, then use one of the decorators like add tool. I'll show it to you in the next module. This is just for the sake of understanding of how it works.
And also because at the end of the like in the API provider's backend, this will all go as a prompt, right?
Exactly.
This will all transform into a text, and it will all go.
Exactly.
Right. So like we could write all this ourselves also and edit in the system prompt.
Exactly. You can do that.
We can respond.
But I can do that, but like, I think this holds more preference because what happens is, let's say, in the system prompt that the model has, like whatever OpenAI has in the background, that is tuned to respect this more in a way. So you can achieve the same. Like, okay, we can try it out yourself, do it yourself. Don't pass any tools here. Let's say when you come here, right? So if you look at this section here, don't pass any tools. Just add whatever you saw there into the prompt in the messages itself, and say you have access to these tools. You can call them when you want. You'll have more or less the same response.
Yeah, I have seen that. So
Yeah, exactly.
my question was more for that. Like, is there any visible difference since you
Yeah.
we have seen in the, like in production. So like is there any visible difference when we define it this way?
Two differences. The first thing is like it performs well, maybe because the system prompt that they have internally prioritizes this, first of all. Second is if you pass the tools here, the response that you get is a structured response. So they'll always return they can't give you a false tool call message, right? So like if you do it with the prompt, the agent might hallucinate and might give you, let's say, maybe a slightly different function name, different parameter name. So then you can't control that. But when you do it using the tools section, OpenAI validates itself on their backend. So whatever response you get from the tools, in the terms of tools to call, it will never be a wrong name, never be a wrong parameter.
And one thing that question is more
Yeah.
related to Composio itself. So this tools that you're providing. So basically, it's basically
Mhm.
like, and specific to this example, the file tool, right?
Yeah.
What does this? Like is it like how is it different from the file system MCP server that is?
It's not too different, not too different.
So which would probably.
Yeah, you can choose whatever you want. Like this is just me using Composer right now. You can just choose different file MCP servers, whatever.
So in terms of Composio's toolkit,
Yeah.
basically all the toolkits, like is it different from that? Like basically.
Yeah, in a way, I think we can talk about it after the workshop. I'll tell you like some optimizations. Like, for the interest of time, I'll just like move to the next, right? But you can come ask me later on. I'll just tell you what the differences are. But anyways, I think once you understand this, like this is the only purpose is to make you understand what's going on in the background. But now we'll switch to the second module. But before that, any questions so far on how this loop works? I'll just quickly iterate on how this works again. So we check the response for any tool calls. If there are tool calls, we handle these tool calls. So what you do is very simple. You just check for tool call in message tool calls. You find the function name, and you just do some searching here. So if the function name is run Python code, you call run Python code yourself. As I said, like the LLM can only tell you what to call and what to call it with. Then you take it out, you take the parameters from the response, you take the name of the function from the response, and then you call that function, get a result back, and then you said like you send it back to the API using this format, role tool, and you send the agent back. And this is a loop. This keeps going on until there are no more function calls left, right? That is the idea. Very simple function. Let me just run this for you to make sure you understand how this works. So what I'll do is I will cd into the toy example. You should now set your OpenAI key and Composio API key in the terminal or through the environment file, whatever you prefer. Very simple. And then what I'll do is I'll run this basic function here. So Python coding agent, right? So what you can see is like in the first iteration, agent is calling tools. Agent calls the run Python code first, because generation of the code is something that the LLM can do by itself. So generated the code first, and the first tool it called was run Python code to make sure that this whatever code it generated was actually right or not. So it calls the run Python code, it executes this is prime function, gets a result back, and then the next time it also calls another tool. So it's trying to figure out if this is right or not. Ultimately, it calls Composio's create file because it wants to write this code to a file now, right? So it calls create file. Ultimately, you'll see a file is created called is prime. So all we did was just create an agent which can write your own file. So we're getting there step by step. So I executed this agent and it created a file called isprime.py, and it ran, and the code which it has here has been tested by the agent as well because it has the run Python code function. So in this demo example, what the agent did was figure out what code to write, run that code to figure out if the code works or not. After it has done that, it then writes it to a file. So a very simple coding agent is here, right? So that's the idea right now. So now, once you've seen that, any problems so far? Anybody has any questions on how this is working?
Getting the data file to read file.
File tool?
Read file. No metadata form for in a file to read file.
Deprecated action.
One second.
What are the list of latest actions?
I think did you run requirements like pip install -r? There's a requirements file in every module. So before you run anything, you just
This is the one, the outdated file to
can you pull latest?
I think they'll have to do Composio apps update. Sorry,
No, I think just git pull करने से हो जाएगा. I think this is an old code, yeah, very old code. Yeah. Just do a git pull. I think the latest repo. Everybody should be on the latest repo because I've been changing a lot. So just pull the latest one today. I think that will solve most of your problems. Well, I'm running the same workshop here.
Has anyone code are running? Because you're running.
You can try it out. Try it again. Like if there's some problems, we'll help you out with it.
key is not working. That. Yeah, the.
It's like bit.ly. Let me just write it again.
But yeah, can someone verify the key they got from URL is working? Your own key. Oh, okay. Is anyone using Composio's OpenAI API key? If anyone using, can just say confirm if it's
This is where the gist is for the API key.
You're using it. No.
So I'm having this issue where it says if
Okay.
it says actions cache is updated with setting cache. Is that supposed to take a lot of time or?
No, shouldn't take too much time, I think.
Because I tried it a couple of times, it seems to get stuck.
Okay, I'll just be there in a second. 1 second. The keys aren't working for you. Let me. I'll just give you a new key. Yeah. What really? Itna jaldi? I'll just make a new key. I'll just make a new key.
But expand the key.
I'll just make some one. I'll just set up a few more keys for you to use. Okay? Okay, so you can.
You can use Composio.
I have updated this link now with 3 more keys. So you can just choose one of the other keys, and I think hopefully that will do it. And we have enough quota. I think shouldn't be a problem.
So the issue I'm having is
Yeah.
that I think the keys are all right.
Okay.
Backend.composio.dev endpoint I'm panning out.
It's an organization.
Backend was it? Timed out.
Yeah.
Okay, interesting. Viraj, backend Composio.dev is timing out for them.
I'll check that. But the OpenAI key is also like
I've added 3 more keys to this link now.
added.
Yeah, at this link there are 3 more keys now. If you go to this gist, you'll find a bunch of API keys which you can use.
So that backend,
Yeah.
do I have to be on the local Wi-Fi?
No, it doesn't work like that. You can be anywhere. Yeah.
But if you use Composio Wi-Fi, it's like kind of fast. So
Yes, faster so you won't face a lot of problems.
right now you're between migration. The older backend is not.
Yeah, just use this Wi-Fi. I think this is way faster then. Could be a network problem as well. But apart from that, like everything else works. Like, can we run the first example, everyone? Because if you can run this, other modules will be easier to run as well. For OpenAI,
Yeah, OpenAI API key.
I just copy pasted the whole thing.
एक काम करें नहीं बना ले.
No, I like 3 more. I like 4 new keys there.
नहीं बना ले सर.
Okay, I'll just make a new another one.
ऐसा तो मैं और बनाने को बोलता हूँ. And like tag them as a workshop so बाद में.
मैं कर रहा हूँ. Keys. I added one more. Yeah, I added a bunch more. I've added one more. Can you check? But no, I think should be fine. Like,
नहीं, there's an organizational level quota ना.
बहुत बड़ा कोटा है अपना यार.
ऐसा है क्या?
हाँ, बहुत बड़ा कोटा है. इतना इधर नहीं होना चाहिए. I think should be fine. Like base. I think the highest tier.
I think enterprise tier.
Yeah. Yeah, like I haven't faced any quota problems in our API key.
Like we internally use our own agentic systems.
हाँ, तो we run like insane amount of agents. वो यार इससे कुछ नहीं होगा. बहुत कम API calls. Like we make insane number of API calls daily. Doesn't matter.
Should be fine. कैसे हो सकता है bro? Can you check what?
So it's like I have done this the Gemini search. So it's showing that it's hard coded in the main file.
Which one? Sorry.
The first one.
Yeah.
I have copied it in Gemini. So it's showing that it's hard coded in the coding agent .py somewhere.
1 second.
Because I have copied the new one also. It's showing the same error.
I don't see it there though. There is no API key here.
API key invalid आ रही है. Can you just like create a
Bro,
fresh one and edit
bro
at
मैंने
the end?
5 नए fresh बनाए हैं bro. What the fuck is
Edit
going
at the
on?
end.
No, मैंने बस copy किया है literally.
कैसे invalid आ रही
पता
है?
नहीं bro, मैंने literally ये copy किया है यार. Because see, I'm just doing this. That's it. That's all I'm doing.
वगैरह check करता हूँ. फिर भी डाल दें.
I'm just adding new keys left, right, and center. यार. See test. Viraj. Yeah, 1 second. Srujan, something is happening, bro. Like all my keys deleted.
What?
All my keys are gone.
Which case?
जो मैं मैंने सब उड़ गया. कहाँ गया keys? Is someone deleting the keys?
No, bro.
I just added like 5 keys. None of the keys are here anymore.
ये अपना
See, yeah. Composio और क्या bro? Test workshop, default project, create secret key. ठीक है. Now it will vanish, bro. अपने आप. In a second it will vanish. कुछ देर वेट करो चल जाएगा. I'll just give them one of my keys, bro. Fuck it. Let's give them one of my keys.
will expire later. Existing keys में से कुछ दे सकते हैं.
But I'm not sure वो की कहाँ है, bro. चोरी हो रहा है. वो कहाँ से आया है मुझे नहीं पता.
स्टेजिंग वाला दे दें. अपना डेव वाला दे सकते हैं ना.
दे सकते हैं. W Z F. Well, I'll just give you one more key. I think this will work. It's something that I have personally. Okay, can you now check? I have a key which I use personally. I think this should definitely work. This will not go away. This is my personal key, huh? So, if this doesn't work, something's wrong with OpenAI today. मैं दे दिया. I've updated it with my own key. This should work. This runs in our systems. If it doesn't work, our systems are going on anyway. ये तो चलना ही चाहिए bro. There's only one API key, na, Abhi? Works, na?
Can you try the latest one?
It worked once. And the invitation to email. It gave me the code. I asked it to write it.
What the fuck, man?
Iteration 1 it gave me the code. Iteration 2 it saved.
OpenAI is really innovative.
Still showing the invalid API.
Okay, never mind. I think let's move on to the next module. Doesn't matter. We'll sort this out later on. Okay, we'll create another one key. We'll add a new key later on. I think let's move on to the next module. Don't have to worry about this so much. This is not really the core of the workshop anyways. Okay, never mind. I think let's go to the next one. Don't worry about it. So we will sort this problem out later on. We have enough keys. Okay? Okay, anyway, so like with the first module, like what we saw was a very basic coding agent. It writes files, it knows how to like test code, everything else is there. And like what we'll do now is figure out like what are the optimizations you can make on top of it, right? So like we now thought about a bunch of tools here. We thought about web search, code search, this and that. So when you have a bunch of tools, usually it's a good practice to split them up into multiple agents instead of having just one agent, because there are a few reasons why. So what I'll try to motivate now is when to use multi-agent systems and when not to use multi-agent systems. So far what you have now is a very single basic agent which does all of these things. It has a run Python code tool, it has a bunch of file tools, right? So now we'll try to see when does multi-agent come into the picture. Like you must have heard a lot about multi-agent systems, how they work, but now what I'm trying to do is motivate when to actually use them in the first place. So I'll just wipe this up. Let me talk about, but so far does anyone have an intuition on when to use multi-agent systems instead of a single agent system? Like, what is your intuition on like when this thing comes into play? And that's a good point. Like when the context window is too large, let's say for a given agent, that is true. Like even though the new models have a huge context window, like 2 million for Gemini, but even then it might be the case that it surpasses that. That is also true, 100%. But any other intuition? Go on.
I was guessing things like, so that is basically, it's a complex problem, you want to make it into some
Yeah.
sort of problem. What I think is maybe you want agents working in parallel.
Correct.
Maybe
Agents working in parallel also a very good point. So you can have like multiple agents, but you can also have the same instance run it twice, right? That is something you can do. But I think look, what you said made sense.
So you mean different types of agents?
Oh, different types of agents. Okay, makes sense. Yeah.
Okay.
No, I think that also makes sense. Like having multiple agents is also a benefit when you want to run them parallelly. That is also true. But other than that, I think the major reasons for why I feel multi-systems come into the picture is that, first of all, separation of concerns. So just like why you have different microservices, that's why you should also have these. So from a personal example, so we're building this agent which can write integration code for us at Composio. So what that agent system looks like is that if I give you an app name, let's say if I want, let's say Composio should have an integration with Book My Show, for example. I want a Book My Show tool, so Composio should have integration for that. So what my agent will do, first of all, is it will go to Book My Show, create an account on Book My Show, because it needs credentials from Book My Show to be able to test whatever it builds, right? So there's one agent which will go, and the only purpose of this agent is to go to the website, try to log in, try to solve the CAPTCHA, whatever there is, and go create an API key, for example, or an OAuth app, whatever that is, right? Once those things are there, then I can give it to some other agent which can write the code for it, then test the code, then publish it to GitHub, right? So that is the whole process here. If you imagine the whole system was just one single agent, then can you imagine what the prompt would look like? It will be a humongous prompt, right? Because you need to do, let's say, browser tasks, you need to write code, then write code in a certain format, because we expect the code to be in a very specific format for Composio, right? Then there should be a code, like there should be prompt which also tests this in a very extensive way. So wherever you see there's a separation of concerns, like there's a huge set of tasks you need to perform, that's when you need a multi-agent system, first of all. Because then what we have seen is that if you give agents personas, they perform really well. And this is something you see even when you use simple LLM calls. So when you talk to ChatGPT, you say, okay, you are an experienced developer. Because what we see is it triggers certain neurons, like certain neurons in this whole network, which makes it perform better when you give it a certain persona. So that's why I think primarily in my personal experience, that's the biggest advantage to having multi-agent systems. Give them personas, first of all. The second thing which I also feel is very important is that cost management. So let's say if you have a set of tasks in which some tasks are more trivial than other tasks, you don't want a very expensive model to be performing all these tasks, right? For example, let's say the agent I mentioned earlier, right, like the browser agent, which goes to create an account on Book My Show. You must remember that whenever you go create an account, you usually have this step where you have to verify your email or pass in some passcode, right? So that's not really a super hard task to do. All an agent has to do is just make an API call to Gmail's API, get the code and send it back to it, right? So, but the browser task is a bit more complex because the browser has to navigate through files, navigate through pages, enter details from some other agents. That is a more expensive task to do. So if you imagine if there was a whole single agentic system, which is using, let's say, O4 mini or like O3, which is a very expensive model. If I was using this model for the whole system, then even for the Gmail task, even for the smaller trivial tasks, I would still be using a very expensive model. But if I have a multi-agent system here, what I can do is I can define, let's say, one agent, which is a planner agent or whatever the browser agent is. This will be given, let's say, O3, which is a very high reasoning model. And then other agents could be, let's say, email verifier agent. This could just be a GPT 4.1 mini, which is a very simple task to do. So now what I'm doing is I'm saving a lot on money because these calls are getting way cheaper, 10x cheaper than whatever this is. And so cost management is one of the points. There's separation of concerns another point. And the third, which I also feel is right, is easier to debug. And this is a bit of a contention. Some people don't agree, some people agree, some people disagree. I'll talk about the cons as well later on. But I feel it's also easier to debug because let's say if you have multiple concerns in a single trace. So I'll come to what a tracing is, how to trace your agents later on. But usually it's very easy to debug when you have, let's say, multiple agents put together. And these can, you can just go to a specific agent's trace to see, okay, how did this perform? If something fails in a certain step, for example, coming back to the browser email verification step, if I find that the agent system is not able to verify the emails, I can just go to the email agent and see, okay, what is the logs for this agent? Is it performing well? Is it is it having a wrong API key, for example? All is very easy to track if I have a different agent, different traces, different logs, right? That is the idea. But okay, so enough motivation around these. There's also cons to multi-agent systems. It's not really a silver bullet, so don't just put multi-agent system everywhere. But we'll come to the cons after we look at the implementation, right? So let's get to building some multi-agent systems now. For that, what I need you to do is go into the second module, and the first thing you do is again do a uv pip install. So I'll cd into my second module. I will run a uv pip install requirements, and now this will install the OpenAI Agents SDK into your system. So as I said before, we're no longer going to use our own agentic loop because we don't want to manage that. Many frameworks do that for you, and I think personally I like Agents SDK from OpenAI and Google ADK the most, because like they have some advanced controls that you can leverage. Let's say callbacks, lifecycle system, all that we'll see in the future as we keep progressing through the modules. You see why I like these two specific frameworks a lot. This whole workshop is in OpenAI Agents SDK, but feel free to like experiment with the ADK or some other workshop, sorry, any other framework that you want to implement with as well. But like for now, let's just use OpenAI Agents SDK because it's very simple to use.
So one suggestion which we keep on hearing is when someone is starting to build the agent, it's better to do something like your module 1
Exactly.
from scratch.
Correct.
And then probably in future, as things become complicated, people can move to a agent SDK.
100%.
But then there are recommendations where they say, okay, don't use agent SDK at all.
Yeah, I think like it's a matter of preference. So what I've seen so far is that I prefer Agents SDK because it's very easy to start with. So I think most frameworks are very hard. Let's say LangGraph I don't recommend at all, because LangGraph is a bit of a pain to understand what's going on. You have to construct edges, you have to construct this and that just to make a simple task happen, right? So those are frameworks that you recommend against. Unless you have a very specific workflow in mind, unless you have, let's say, a fixed definition of how to go about doing things, you should not use a framework like that. But for example, Agent SDK is very simple. I'll show you how it's defined. It's super simple to work with, very simple functions. So you can just use that whenever you want to do. But usually, as you said, like, it's a very good idea just write everything from scratch. Because once you write this one loop, I showed you this very single loop. Once you write that, everything comes clearly to you. But why I feel that you need to know Agent SDK is because of the other features I'll talk about. So the other features I'll talk about in the future, like state management, lifecycle callbacks. For example, something you want to run after every tool ends or before every tool starts. So all those lifecycle control that you have, very hard to implement yourself, and there's no reason to do it. Like these agents make it very simple for you. And again, as it is defining the JSON for every function you write is also pain in the ass. Like why you have to do that? So like you can just define a Python function. These framework handle the conversion from the Python code to the JSON, whatever is used by them. So even if the API changes in the future, your code doesn't break because the agent frameworks handle those things. So
And the effect tracing happens in OpenAI environment.
exactly. So tracing is also, there's a lot of benefits that come with frameworks. They don't get out of the box. So if you have a very simple use case, fine, do your own agentic loop. But if you want to building a production agent system, then you need to use one of these frameworks. The simplest one of them is Agents SDK in my opinion, but it gives you a lot of great features out of the box.
Actually, at the fundamental level, maybe we
Yeah.
should have taken it on the first this only. But I am not exactly sure how do tools and MCPs differ from each other. Is
Okay.
it like tools are for
Very good question, I think.
LLMs and MCPs interact with agents? Is it that sort of a thing, or
No, I think it's MCP is just tools. So like so like tools feed into MCP. So MCP, all that MCP is like a contract which you can give to an LLM. So whenever you add MCP to an agent, right? Let's say when you add MCP to Cursor, when you add MCP to, let's say, Claude Code, all it does is it gives the Claude Code access to, okay, this is an MCP server that you pass to the Claude Code or whatever agentic system. What happens is it just gives Claude Code a list of tools that it has access to. If you look into an MCP server, you'll find a list of tools. Exactly. So an MCP server is just a contract, just a way of representing these tools to a specific agent. So as you saw earlier, like we also added a JSON here, na? We added a JSON which we passed to the LLM. So MCP server is just a way of controlling the list of tools. So it can be dynamic. So you can add, remove tools in the future. You can add updates to the server. So it's like a better way to manage tools essentially.
so? Is it accurate to say that if I'm using someone else's agent, I will
Yeah.
probably give him an ACP and MCP? If I'm writing my own agent, chances are I'll be using tools directly.
No, you can still use MCP if you're writing your own agents. The difference here is like if you want to implement the tools yourself or if you want to use somebody else's tools. Because I'll tell you why. For example, let's say if I'm using Salesforce MCP, for example, if using, let's say, GitHub MCP, whatever, right? I don't want to know how this tool is implemented, first of all. and I don't want to maintain updates to it. For example, let's say if GitHub has a new API tomorrow, if they have some new functions coming in, I don't want to write another function which mimics that API or calls that API. I can just, when I'm using GitHub's MCP server, that server will get updates from GitHub. So it has a server push functionality. So whenever GitHub adds something new to their MCP server, your agent will just get that function right away.
Like if you want a higher level of abstraction.
Yeah, there's a level abstraction up on top of tools. So you have tools which are the building blocks of MCP servers. MCP servers just represent the tools to the agent in a nice way. And they handle things like updates, they handle other things as well. There's like resources as well. In addition to tools, you have some resources as part of the MCP server, but that's a different workshop altogether. So I don't want to go into MCP right now. But you're right to question that. I think this is just an abstraction on top of tools, another layer on top of tools, right? That is the idea. Okay, so this is done. Getting back to our multi-agent system here, as I said, we're going to use OpenAI Agents SDK to start with because it has a lot of benefits. We'll come to the benefits right now. But I want to show you what a system like that looks like. So let's just write some code together. So what I want you to do is, like, first of all, let me show you what a multi-agent system looks like. So 1 second. Oh, it's opening here. Never mind. Okay. 1 second. Cool. So here, I'll just quickly show you. We'll copy the code from the previous thing. We already have run Python code from the first toy example. You can just copy that right now. And the same file tools from Composio that we saw earlier, same thing. Now let's look at this code here. So I will show you just one of these, and then you'll write your own agents after that. We'll spend like 5 minutes, 10 minutes writing our own agent codes. You can choose to look at the code as well, but that's up to you. But you can also write your own code after that yourself. So what you see on line 91 is a planner agent. So I chose these different agents, but you can choose whatever agents you want. So usually you think about separation of concerns. Okay, when I'm writing a coding agent, what are the steps when I'm doing it? Like the first step could be planning the whole thing out. So if you give a complex problem like I want a portfolio website, I want this and that, the first step when you do is as an engineer yourself is the first step is you write a plan. Okay, so it will have like these 3 objects, it will have these files, it should have this structure, you do some planning first. And once the plan is right, you then start executing it. You start writing code for those files. Once you write some code, then you write some tests for those code. Then you run those tests, see if the code works or not. If it doesn't work, then you edit the file again, right? So this is the usual flow that you go through as a software engineer yourself. So I'm just mimicking that into agents now. So the first agent I wrote is a planner agent. And how I wrote that agent is very simple. I chose, one second, I'm just messing the wires up. But anyways, yeah, the first thing I wrote is very simple. So you import agent from OpenAI Agents SDK. So if you look at how this agent is defined, this is the class inside OpenAI. So what you do is if I go back, 1 second, let me cross this. So agents is imported from OpenAI. So you can see I import from agents, import agent. So all of the loop that we saw earlier is now part of this abstraction that you can use. So you come here, you define an agent like this, you give it a name. So this is a class which is exposed by OpenAI. And what you can do is you can give it a name, you can give it some instructions. Instructions are basically your system prompt. And then you can give it the tools, as I said before, there's a tools option as well. There's a model and there's a handoff description. Right, so this is how you define. Like before if you come to handoff, I just want to show you what this looks like in the outset, right? So any questions so far on how this tool is defined, what it does? So whatever we saw earlier in the past example, all of that is encapsulated into this one single class. So there's no agent loop, nothing else. All you need to do to create an agent is just this. Take an agent class and then fill it up with these details. Planner is a planner and there's a model here. Right, so as I said, model can be chosen based on the concern you have. For example, for planning, I'm choosing a reasoning model because I want a detailed plan, all things considered. So I'm using a O4 mini here. But now, before we move on to implementing other agents, I think the other agents you will implement yourself for now. We'll do that together. But before we do that, I want to make sure you know how, I'll just remove this chair for a while. These wires are messing it up. 1 second. A lot of wires. 1 second. 1 second. Fuck that. It's messy. Never mind. It's a huge wire row. Perfect. We'll take a break after we do this, so we'll have enough time to relax as well. So before we, very important step in multi-agent systems is how do the agents talk to each other? So let's say even if I define a planner agent, a coder agent, how is the communication happening? Because earlier we saw an agent loop, right? The agent loop only had, let's say, single LLM tool cycle. How does this interact with some other tool cycle? Right? So how does it know some other agent? How does the communication happen? Those are things you need to understand first, right? So there are many patterns that usually people follow. I would recommend that you look at Anthropic's Building Effective Agents. That's a really nice blog post which talks about a bunch of things. So I'll just quickly talk about a few here myself, then we'll go through the blog post later on. So I think one pattern which is very prevalent, I think OpenAI Agents SDK supports this by default, is the handoff pattern. So what this means is that you define, let's say, a planner agent. Let's say there's a coder agent which codes it up. Let's just imagine two agents for now. Very simple agentic system. A planner will write a plan, validate the plan. Coder will write the code in the files, whatever that is, right? How they communicate is, what you do is you add a handoffs parameter and you give it a list of agents it can hand tasks off to, for example. And you can do the same for coder as well. So let's understand this first and then we'll look at code on how to exactly do it. But for now, let's just go through a theoretical discussion on this. So what happens now is that I'll ask you for ideas as well. So I add a handoff here to the planner agent and I say, okay, you can hand this off to coder when you want to. How do you imagine this communication happens? So based on all that you know right now, what an agent is, how it works internally, how would such a system work? Can you think about it? Exactly. So this is also be a function call, right? So the key to understanding agents is you have to understand how it really works. All this is just an LLM with a bunch of tools, nothing else. So any agent you see on the internet is just this, LLM and tools. So any fancy function it does, let's say handing it off, this and that, everything is just a tool call in the end. Literally a tool call. So when you add a handoff called coder to this planner object, which is OpenAI's agent, all OpenAI does in the background, if you look at the code yourself, it converts this into a function called transfer to agent. Transfer to agent. It just adds another tool to this LLM's toolkit. That's all it does. So it tells it, okay, you can call this function with a specific param called coder, let's say. And inside this definition is something OpenAI has implemented itself. And what this thing does, it just calls this coder's loop, essentially. So when you run this coder, it has its own loop, right? So all this function does, which is passed to this planner LLM's tools, is that it just calls coder's loop with a specific input. So when this LLM tries to talk to coder, it has to provide two parameters. One is the name of the agent, which is coder. Other is the message that it has to pass to this other agent. So this message can contain the whole plan, right? So when this function is executed, it just calls the coder's loop with this specific message, and that's it, right? And the same happens with here as well. So like it also gets a handoff to the planner. So it can also, this is how they talk to each other. They just call these things, and OpenAI manages the state in the background. So when the coder calls the planner, it knows all the previous messages because the messages are being tracked by OpenAI. So all this complexity is handled by OpenAI. That's why the SDK helps a bit. Right, so ultimately you're right. Ultimately everything is just tool calls, prompts.
So here what I want to understand
Yeah.
is parallel and coder, they are working in parallel, or it's like first parallel, the planner is instantiated,
Yeah.
it executes a bunch of things, then coder is instantiated.
It can work however you want it to work. So ultimately, here what is happening is you create all these agents at one go, right? You start these agents. You have to understand this is very stateless operation. So every time I say an agent, right, it just means a bunch of prompts and tools, and whatever messages that this agent knows is whatever you sent it in the one API call you make. So every API call you make, whatever set of messages are being passed, that's the whole context it has ultimately. So everything is very stateless, right? So what happens now, I'll tell you what the flow looks like. The planner is running, and by running I mean you give it a prompt first, LM gave a response back, and LM ne bola ki okay, I've made a plan. The next tool I call is transfer to agent because I want to transfer to coder, right? So it calls transfer to coder. The agent's SDK in the background then calls coder ka loop. It starts the coder ka loop with all this context. So whatever context you had, the whole plan, it takes the plan, gives it to the coder as a first message. And now coder is running with this message. Okay, I have the plan, I have this thing. Now coder runs this loop. Now when the coder is done with all of that, writing all the files, it then knows, okay, I have to call the reviewer agent, for example. Or maybe the plan is not right. It wants to go back to the planner and say, I need to change something, right? So when you pass this message, OpenAI will handle all the context and will give it to the planner. So there's nothing running. There's no perpetually running process, nothing like that. All you do is just transfer of context from one agent to another agent. And the context happens through the whole message that you send. Understand?
So what if in the case of
okay.
local LLM?
What if you use local LLM?
I mean,
It's the same. It's the same. So ultimately, as I said, like, it doesn't matter where the LLM is deployed. It could be local. It could be anywhere online. My point is that there is no state. There is no running LLM. LLM is just one API call. Whatever context you give it, that's all it was.
Now
all graph
Mm-hmm.
thing. So that leads me to ask, like for example, let's take 3 agents, just planner, coder,
Correct.
reviewer. Okay. So when you have functions, like if it's just functions calling other functions, there's
Correct.
a planner invoke function, there's a coder. Sorry, what's the name of that?
Planner, coder, and reviewer, for
No,
example.
the
Or transfer to agent.
Huh?
Transfer to agent.
Transfer to agent.
Yeah.
So it's all a bunch of transfer to agent calls.
Exactly.
Does that mean, like the way in a recursion or in a function you traverse the tree and it has to come back? So is that still
It has to
here?
come
Like,
back.
for example, because if we just say functions, that's my next question that comes to mind. Is that still true or?
No, I think coming back is not really a traditional stack calls. Like it's not like you maintain the order of stacks and then you pop it out. It's not like that. It's just a simple function call. It goes to the coder. Whatever response it gets back, it hands it off. So that's where the pattern comes into the picture. Like hold the thought there. Whatever thought you have is a very valid question. But that's where the patterns come, because how you want to make this work is up to you. So you can either have, let's say, a sub-agent system where there's a main agent. It calls the sub-agent, gets the response back, then it does some other step. Or you can have like peer-to-peer or hierarchical. You define your patterns. I'll just come to that in a while. But then all of those communication that you want to have, it's up to you. You can define it in a hierarchical way that, okay, I'll just get the responses back and then I decide on something else to do, call some other agent. It could be peer-to-peer where they have independent context. This agent doesn't know anything about this context. They both have independent context. So you can have merged context. For example, let's say if I'm the main agent and I want to know what's happening in the sub-agents as well, I can have that context transferred to my agent as well. There's a lot of flexibility in that. So you can choose however you want to make it function. So that's when I recommend like this blog post I told you, like the Anthropic's building effective agents. They have a bunch of patterns there. So they have, let's say, an orchestrator worker pattern. When an orchestrator orchestrates work to some workers, the workers send the information back to orchestrator and decides what to do next. There could be like a, I'm not sure, I don't remember the names anymore, but there's a peer-to-peer network as well. There's a workflow as well. So it defines what a workflow is, what an agent is. It's a very nice article. I think it's like a holy grail of building agents. Like,
So since we are talking about the article, first thing it suggests is don't use agents.
exactly, workflows.
So what's your thought on that?
Yeah, I think I totally agree with that. I think when to use a workflow versus when to use an agent is very, okay, the question I ask myself usually is this. Do I know exactly how the system will work? Like, do I know all the steps in the pipeline or do I not know the steps in the pipeline? If I know the steps in the pipeline, if I know that, okay, first ye hoga, then this will happen, then don't use an agent, because you're just defining a workflow right now. So like first step is this, second step is this, third step is this. Maybe there's a loop back if you want, but then this is how the flow looks like. But if your workflow is very dynamic, like if your workflow will change depending on the output of an execution, then use an agent, because an agent only comes into the picture when you need to have a dynamic workflow. Like I don't know what will happen now. Let's say a planner made a plan, coder coded up a plan, and there's a reviewer. Reviewer said, okay, this plan is not right. The plan itself is faulty. Or it might say that the plan is right, the code is faulty. Then it might go here, or it might go here, or it might go this. Like there's multiple paths here. So when you have many edges and there's no single workflow defined, that's when I prefer using edges, because then you can have dynamic decision making in the plan. But if I already know that this is the flow, yahi hoga, and this will maybe call back this definitely, then I just use a workflow, because it's way cheaper to just use a workflow, and also more deterministic. Because here it's not deterministic at all. It might choose to call a reviewer first if the model is not super nice, right? It'll break your system entirely. So you're trading off determinism with, let's say, dynamic decision making. So if you want system to be more powerful, use agents, but then it comes with its own cons, like not deterministic, expensive. So you choose that based on whatever your use case is, essentially. But yeah, if workflow works, use workflows, 100%. Make it as simple as you can, right? Okay, where was I? Okay, so we defined this agent. We talked about some patterns. There are more patterns, you should explore them yourself, like see what works for you best, choose workflows when you want to use workflows, choose agents. Even within agents, you can choose what patterns you use, hierarchical, this and that. But for now, we'll choose very simple handoff pattern. So as I said before, we'll have an agent planner, and it will have a handoffs array, which will have a list of handoffs. Same is true for coder. And there will be a triage agent, which will be like a orchestrator that I want to build. This agent will have handoffs for all these different agents, planner, coder, whatever. So what I mean with the triage agent is that it will try to hand off tasks based on specific things. So this will be maybe a reasoning model or an ISM model, whatever you want, you can choose for that. But the point is that you will talk to this agent first. So the first two that you start will be with the triage agent. You will send a request to this triage agent. It will then choose to delegate the task to whatever agent wants, whatever it feels like. And then these agents can also talk to each other. So it's like a very peer-to-peer system that we're going to build now. Very simple. And how you do that is very simple. I'll show you quickly. I showed you the planner agent already. Now let's try building a code agent ourselves. Right, so like how would a code agent look like in this scenario? So let's create a new file. I'll just use this as a reference. I'll just copy this. Okay. I want you to also write some code yourself to get a hang of how things will work. Right. So I'll just copy this. I'll open a new file. I'll paste it here. Right. So this is a planner agent. I want you guys to write any other agents you feel are important in this setup. So there could be a coder agent. Let's write a coder and a reviewer agent, right? So like I want you to spend 5 minutes, look at this code here, and then think what tools would the coder agent require without looking at the reference code, and then figure out like how to write an agent yourself. It's very simple, right? Just similar pattern. All that will change is the prompt and maybe the tools. And even for that, what I usually do, I'll tell you what I personally do. I dump everything in the prompt. So it doesn't have to be perfect prompt. Just write, okay, I need a coder agent. Quickly type some things out. You should do this. Sab kuch likh do. Once you've written a whole dump of your thoughts, copy it entirely and ask any model to edit it. Let's say ask O3 to like optimize this prompt, remove duplicates, remove redundancy, make it optimized 100%. And that's the flow I usually take. Because in the course of development of agents, you will discover many edge cases. So you'll start with a single prompt, very basic prompt first. And you'll notice, okay, this is not doing things in the right way. Isko aisa karna chahiye tha, it's not right. Don't stress about it. Just write the whole edge case down. Okay, I saw a case where you did this. You shouldn't have done that. Do this instead. So eventually, through like 5 or 6 iteration loops, you'll come with a dump of a whole prompt, which will be like a bit messy. Some points will be repeated. Some will be highlighted, important. Don't do this, and that. So you'll arrive at a very messy system prompt, and then take that prompt, ask O3, optimize this, and you'll get a very nice looking prompt like this. I did the same with here as well. So start with a very fresh, random thoughts. Just jot them down, or if you're using WhisperFlow, just speak it out, and like write them down. And then after that, have a model which will like format this very well. Okay, that's the idea I usually do. So not a lot of writing yourself actually. You can just like make it a bit faster through that message. So I'll just spend 5 minutes. I'll come around, try to write a coding agent if you want, and what the prompt would look like. Just think about the tools that you want to build with this agent, and then we'll like move into looking at the patterns and how the handoffs are performed. Right? Actually, should we take a break? We should take a break now, right? A break kar lete hain. It's already 4. I think we're a bit behind the schedule. Yeah. Yeah, I think we're moving a bit behind the schedule. So we'll take a bit.
But yeah, we have chai and snacks upstairs, and you can take a breather. I think it's a 15 minutes, 20 minutes break.
20 minutes break, I think we're fine.
Yeah, 20 minutes. So since we are late, we'll start at 4.
Yeah, I'll start at 4 and start at 4:20, right? No?
Yeah, we'll start around like 4:15, 4:20.
Yeah. So you can break for now. I think write the agent. Like it's very short. Yeah, but it's very short code anyways, and it doesn't take too much. Like just look at the reference we want. I just want like some hands-on experience and not just all lectures. So try to get a hand of it. Like it's all up to you. Like responsibility of writing code is up to you. You can choose to just look at the code if you like that, or I can't really come to you, man. Like I'm tired. Yeah, you should take a break. Go out, take a breather, look at the sky, and then write a simple agent. Like the coding part is very simple, to be honest. What I want you to understand from this workshop is how these patterns work, what the code looks like, and then you can write your own when you go back home. Like you can write your own versions of it. Because there's no point writing a whole system here, in my opinion. Like it takes up too much effort. You can like just know how these things work. Write a small snippet of code to just understand how the API looks like, what are the parameters, how to use Composio. All that is really important. Other than that, like, I think it's fine. Yeah, you can take a break now. There's snacks upstairs. We can come back. We'll reconvene at 4:20. Okay? And I'm here for any questions or anything else.
For Lambda, they say a lot of things are getting deprecated. Is that an issue?
Yeah, I think the issue is that you should not use LangGraph at all. Yeah. I think LangGraph doesn't make any sense to me. Like it makes sense when you have a very specific workflow in mind. Okay, I want to know, okay, I have to do this stuff first, and then the second step should be this. So LangGraph is useful in those parameters when you have very specific workflow defined. But it comes with its own baggage. Like you have to know, okay, I have to define workflow rules. इसमें ये edge होगा, conditional edge होगा, all those things. There's also we have to do.
Does it implement this exactly?
Yeah.
Exactly this.
Exactly that. So like you have in LangGraph you have nodes, right? You have a
Single agent as well.
exactly. So you have a LM node, you have a tool node,
Okay.
correct? And it's the same as the defined here, the loop which we have. So LM node will call, it will execute a OpenAI, it will execute a request to OpenAI, whatever model you have. It will send a response back, and depending on if it has a tool call parameter or not, it will call a tool node. The tool will execute the tool, send the response back to the LM, and then this cycle will repeat. This entirely is an agent. So LangGraph doesn't have an agent-agent abstraction. It has a node abstraction.
and these two nodes put together will make an agent, essentially. So it was like far too complex.
Every small thing is a.
Yeah, it's a node, and you can define like you have more control on how the system works. But then most of the time you don't need that control unless you have a very specific use case.
Using this SSD over there.
It's way simpler than
I agree.
the lambda or Scala because then there's more boilerplate here as compared to like as I told you, this is a single line. That's it. That's an agent. That's all you need. Here you define an LM node, define a tool node, define conditional edges, when to call this, when to do that. Like a lot of extra edge just for a single application.
For your production, you use this.
I use Agent SDK. I use Agent SDK and Google ADK, both of them.
What is that?
Google's ADK. It's also a very nice agent framework. So both of these things are nice.
But what about memory and scaling? Does this language use this?
Yeah, it does some very nice. We'll come to that next module.
We already need that, but not like that.
No, not right. It should be like that. For SDK, SDK is what
I
we
know like framework, that's a lot of things that over there rather than you write it down.
Yeah, the whole benefit should be like it helps you place things better, manages your state, manages the session, because managing the messages object itself is a pain. Because you have to worry about like how does the state transfer between multiple agents, how does the handoff happen. So when you start building more complex systems, that's when the framework actually starts paying more. But for simple systems, it's very easy just to go by your own rules.
And I was just asking about this, you are already implementing code like this, faster than you
So like, this was just a reference for you. So what I wanted, like, my idea was that I can't code the whole system in a workshop. Just let it have some, and they like, I don't expect people to like their own
One
agents.
more thing between basically this idea of bad guy, like internally I want to understand, wouldn't there be a responsibility
I know that from day one.
except like defined what
No, this is a man now.
That is people do not
Think twice before saying
like
stuff.
you're talking about the parameters of the transfer page, which might
Might
not be appropriate. That's an internal function.
like when I'm defining this,
Yeah.
right,
You don't even have a chat.
it might like
That will be a loss.
what kind of response would it accept? Like this code is really wide open without certain parameters.
What it means is that
Bro, when I
calling
say
the agent is very easy
stuff
parameter. When you call the agent, you just pass.
I have to be stuck.
I guess all the tools that is available in that like the handoff agent has to be defined. Right, whenever it is in that let's say in the try agent, right?
Is there something?
Whenever we are
Let's see
defining
the
all the
work.
handoffs.
Video
So
game, no?
basically in that internally basically in the
weird.
it is running like all the
पण बोला तो था ऊपर जाने को but within the system you will go upstairs and as in the
So we're asking how does the prior agent know what agent to pass it to? So we have to make a description. So every agent comes with a description. So what happens is that you want to transfer the agent, the transfer to agent, they looks at the
Just like
definition of
this
the
me.
this is the documentation we get. So they execution check.
Then you execute it.
Exactly.
what arguments
Yeah, he lives with, I live with.
That's the name of the function call and the message to pass. That's it.
oh shit no
What you want the function?
basically what I'm saying is whenever I transfer so there has to be some context from the previous step that has to be passed.
All things
you don't know that there are
all the
multiple
things
reasons
that
why I'm saying like
not even this concept now. I didn't do a message here. This is send text to.
you should do
What happens is when the translation is called, it is called with the name of the agent, send message, and the whole context. There's one parameter or message. I'm not sure what the name is.
But is it only that context is the message that we define the role user, all these things, or is it some output of the previous step is also
I think I'm looking into the exact reason. I'm not so much sure.
Yeah, you should have this Composio one and t-shirt.
actually I should
So like because let me also send you the code.
Can we have your
I'll
update?
start from
I'm not sure myself how the SDK works. It could be sending a bunch of previous messages.
There's some perspective on this.
like let's say like
What is the
I'm building
Oh, yeah,
So
yeah,
we build these agents.
Understand.
I have one agent that is supposed to make a response and fetch all my like another agent who is going to transform it into my
Name it
customized
like
message.
that.
Oh, I like it.
But
But
then
are you
before
not here
this
for
one
the
is whatever it is. Right, FOMO.
So we have
This
tools.
the response is like the full array
Put the
So
relevant
element
keywords at the
relevant sender. So I tell you what.
system.
Element is smart enough. Who decides?
You have no idea how this looks. But me and you sit next to each other.
What
We can use all these agents in all of the
Yeah.
cases. So when he says this handoff tools, right, you don't need to write the handoff tools using Composio. You just say Composio, get the Gmail fetch action, and it will take care of how to.
So
Essentially,
but
Composio
that
is
it
a
understands based on this system
additional
key.
tools
So it knows based on the current
that
situation.
you can use
Something
it
like this,
however
it's
you
like, I want to summarize my
want. We are not
for example.
strict on any agent pattern. So if it's up to you, if you want to use a workflow pattern, you can use it. If you want to use a handoff pattern with multiple
My
You are
question
more
was
of a
how does it
middleware.
understand it
Like implementation is up to
basically
you.
from the
Yeah.
description
You
it
just
is
provide a developer tooling. It's up to you, like however
this
you want to
integration
use it.
sometimes has to be like SDK.
We have an SDK. The one you're using actually.
Needs to
You
summarize.
say the code. Yeah, we have the SDK.
We have that.
So for that, what do we need to do? Also provide all the
So we don't provide LLMs. We don't provide LLMs. What we provide is authentication, hosted authentication, and hosted tools.
You're right.
What that means is, let's say for example, you have an agent which needs to do something in, let's say GitHub. You want your agent to give you like a brief overview of your GitHub report. Some GitHub report. You want to know like how many issues there are, how many issues there are, whatever it is, right? So then you build an agent, you can use the hosted tools we have like
Yes, we have a lot of tools to implement.
There are systems like that. So OpenAI only has the max turns. Because if it has to put turn now, then it throws an exception for that. So it's a very, very valid point. What happens is that. You work with Composio, is it?
I haven't been hired, but I
Oh, I was thinking like accent will be fine.
sure that they're
You only have chance for this event.
just because I was seeking for permanent residency in Bangalore. So looking forward to like new jobs, new opportunities, and I feel like Bangalore deserves some photography, videography. And I was like, this is my opportunity, let's go.
I met some people who are working in the Hasgeek space also.
Okay.
Like same goals.
Okay.
So like I just made friends with Sana. She's also shooting because she wanted to make some filmmaking photography. So she's part of Hasgeek.
Can I not can I get along? I mean, more like marketing and all that.
Can we have you also upstairs?
Yes, chai.
Chai, coffee,
Yeah, so I
samosa.
can have like reviews about how good is the workshop going, how bad is the workshop going. We need an honest reply, okay? ऐसे नहीं कि अच्छा बोल देता हूँ मैं आया हूँ इतना कर ही रहे हैं समोसा चाय खिला ही रहे हैं, okay? Just be very honest, blunt honest. I want reviews.
is all that was needed.
Is that just what it means? So what happens?
And then when I
You run it again. Sometimes we saw also the dictionary because agency usually psychopathic. They want LLMs want you to say yes or no to things. So you can also mention you're completely autonomous. Don't ask them for consent. Then you do everything by yourself. Because because it says okay. If it looks good to you, I hand off to the coder.
right.
And then it expects you to respond back to it. And a system like this is a very simple system. You want it to work autonomously. So do we run it again?
But we have that autonomous wala part.
Let me see that first. Like try running it.
Because I tried it a couple of times. So like for example here, this is the triage one, I believe. Oh, it's not funny.
I think it's fine. वो तो सिर्फ फाइल में working this file जो चलता है सब पता नहीं it's just running it. But maybe I'll look into it in a while. Okay. But you got the idea of how it works. This is supposed to work. Whatever you do right now will work 100%. But getting back, let's assume you got a shot at least looking at the code and maybe figuring out how to write an agent yourself. It's very simple. As I said, simple abstraction that you can use. Define the prompt. So ultimately, all that defines an agent is a prompt you write and the tools you add to it. I'll just wear my mic before I forget. Okay, so once you have the right, sorry, go on. Yeah, 1 second. Okay, so line 91. 1 second. Yeah, go on.
So, the parameter that you're passing to agent, let's say
91.
93.
93. Okay, yeah, go on.
So, agent. So,
Yeah.
all these parameters are just mentioned in docs.
Yeah, mentioned in docs. So what you can do is just hover over the agent thing. It'll tell you what exactly you need. A name, handle description, tools. So this agent is a class from OpenAI Agents SDK, right? So it's not something that we defined, Aj. It's something just use off the shelf.
That's what I want to know, like, where exactly.
Yeah. So okay. So go on.
Can you repeat the assignment once?
Oh yeah, like the assignment was to just try to write an agent by yourself. So the planner agent is already written. I already showed you that code. All agents are there in the file itself, but you can choose to like just write one yourself and then compare to the reference. I just want you to like write some code to understand how an agent actually is written. Because once you just see it, it might not strike you or you might not remember how to do it in the future. But I just want you to like get some hand dirty, write an agent, very basic agent. Huh?
It can be any
Any agent, but like in the context of what you're doing. So I think it makes sense to just write a code agent yourself, because then you'll see how the handoffs are performed, where you define the handoffs, all of these things will become clearer. So
are these classes predefined or
yeah, these classes are abstractions that you get from Agents SDK.
agent is
Exactly. So OpenAI Agents SDK. Yeah. So you don't have to define these agents yourself. That's the benefit of using a framework. You don't have to write things yourself. You just like use this. So an interesting thing here is the handoff description. So while you're implementing, I'll just talk about the handoff description a bit, because you've seen that there are multiple agents here, and they all have the handoffs defined, and the handoffs are just transfer to agent calls. But then how does a triage agent know when to hand it off to the planner agent? So it needs to know what the planner agent actually does for it to be able to transfer to it, right? Like otherwise it can't decide which agent to transfer to. So what you do is like every agent gets a handoff description parameter, and this is what is used by the main agent or whatever agent is trying to hand it off to this agent to understand ki agent ka responsibility kya hai. Like whatever the responsibility of this agent is, it tries to figure out through the description. Because this agent, the try agent can't see all the tools, all the prompts of this agent. It doesn't make sense to do that, right? It only sees the handoff description, and looking at the description decides whether or not to hand this task off to this agent or not. That's where it comes into the picture, right? So if you look closely, like you can just, I assume you already have taken a stab at this agent. So we'll just go ahead with it. I'll just show you quickly. A coder agent is also similar in terms of the planner agent, but it just has an additional Python function called run Python code, because coder also wants to run and see if it works or not. Right? So it has a run Python code in addition to whatever there was existing. And you see I've changed the model here. The model is on GPT 4.1. With the planner I chose O4 mini because I wanted an extensive plan, and planning is usually done by reasoning models better. That's something I know. Right? So like I chose O4 mini for the planner agent. For the code agent I chose 4.1. You can use Claude Sonnet as well because that's really great at coding. So you can use that LLM and then use Claude Sonnet 4, which will produce the impeccable code. So you chose the right model, you chose the right tools, and then I chose a reviewer agent, which just reviews the code and scores it if it's right or not, right? And then what you will see now is when you start creating these agents, right? So when you start creating this is a function I wrote, create triage agent. Isme we define these agents first, and then we define the handoffs. So if you look closely here, you will notice that
I'm creating these agents first, like planner, coder, reviewer, all these are agent classes, right? And what I'm doing now is I'm setting up these handoffs. So what I'm saying is a planner can hand off to coder, right? A coder can hand off to reviewer or planner as well, because it might realize the planner is not right, so it can give it back to the planner. And a reviewer can do both, coder and planner both, because the reviewer might see the planner is not right or the code is not right, so it can do those things. So all you do is you just assign the handoff property of an agent, and the thing is a list of agents. And now it could either be a list of agents themselves or this handoff bracket agents. What this allows you to do is just modify certain parameters like the name of the handoff, everything else. But this could very well have been just this. You could remove coder handoff here, you can just do coder. This is just a SDK implementation detail which you'll find interesting. But you can just define a handoffs parameter with a list of agents you can hand this off to. Right, that is the idea. Once you do this, I have now defined finally the triage agent. And here I define how to do what. Like your job is to triage, like delegate responses between a planner, coder, and a reviewer, and you give the details when to do it. And you give it a handoff property here. So this triage agent can hand off to coder, planner, and reviewer, all three of them. Similar to what we saw earlier. You can either do agent.planners or just define it in the constructor itself, right? That is the idea. And once you have that, once you have a triage agent, then I can just start the multi-agent system. And running the system is a bit different. Like it's not. So how to start this loop is something that Agent SDK has its own functions for. So I'll just quickly talk about that here. So what happens is you have a runner class here. So there's a runner class which SDK provides you as well. And this runner is used to define the run config of your agent. I'll talk about the run config in a while, don't get confused. But the idea is that you define, like take a runner class and you call runner.run. You pass what the starting agent should be in the system. So here the starting agent is triage agent. I give it a user prompt, which is the first input to the agent system. I give it a max turns. So the point of max turns is that we've already talked about how this looping will happen. Like one agent will pass it up to some other agent, it will also an agent. It might be a problem in the future where, let's say, if you didn't define the prompts very well, there might be an infinite loop. Let's say planner built something, gave a plan to the coder, right? The coder tried to code it, figured out there's some wrong things happening, gives it back to the planner, gives it back to the coder, so this loop might keep running on. So you're wasting time, you're wasting tokens. So you want to limit this deterministically at some point. So that is what max turns means. So if you have 50 turns, if you have 50 handoffs, that's where the system exits by itself, because that's probably an erroneous use case. So as I said, like multi-systems have their own cons. We'll talk about the cons in a while as well. So it's not all like green fields. There's like many errors which you can run into with multi-systems, so you have to be very careful with that. So general rule of thumb is avoid multi-systems as much as you can. Only use them when you absolutely feel the need to do them. If you have too many tools, too many different contexts, and you feel that you definitely need different models, or otherwise it will cost a lot of money to you, only then use multi-systems. Otherwise, just go with a single agent system in the future. The cons, first con is like, as I said, there can be infinite loops here. So let's say if you have multi-agent systems, this agent might hand it off to another agent, that might do something, give it back to the agent, this may feel, okay, this is not sufficient, give it back to the agent. Sometimes there are loops like this which form infinitely. So maybe the prompts were not that great, you didn't define an exit condition for these prompts. It might like infinitely try to refine the system.
There can be some exit condition like let's say 30 loops or something.
Exactly, that's what max turns is. So you stop it there. But working like this is still wasting a lot of tokens for you. That is one con. The other con is like debugging. So I said it's also easier to debug, but sometimes some people find it hard because let's say you have multiple traces. I'll come to traces in a while now. But let's say one agent is running in a certain way, some other running in a certain way. So let's say in the whole system, if something is messed up, you have to go to that agent and see, okay, kya hua? And maybe you see that, okay, this agent handed off to some other agent. Then you go to that agent's loop. Then you see, okay, yahan kya hua? Then it sends to some other agent. So debugging becomes a hell. If you have multiple agents, you have to like hop around between different traces to find what exactly happened. Exactly. So you have to like look at different logs. So it's like very hard to manage. Orchestration is a con. So if not managed properly, orchestration is a huge pain in the ass. That is there, in addition to whatever we talked about here. So it's not always a silver bullet, usually.
So when orchestrating, is it like all the systems, like all the agents run in one single system or different infra components?
You can choose to run different systems as well. But for that, you have to set up servers and clients.
So this can be distributed as well?
Yeah, this can be distributed. Like A2A provides a very nice framework for that. I think that's a scope for a different talk altogether. You can come to me later and I'll tell you how this works. But you can choose to deploy your agents in different servers, make them talk to each other, but then you have to implement the server client functionality. How does the network flow between, how does the data flow between the network? That you have to implement. But here, सब कुछ local चल रहा है तो दिक्कत नहीं है. Like it's just a function call. Exactly. So like ultimately, the only thing that will change here is that the transfer to agent function will not just call the coder ka function, it will make a HTTP request to coder. That's all it will do. So you can have remote agents after that. Yeah, go on.
What does run_config do?
Okay, the run config here, right? Okay, so to answer this question, it's best if you just go here. So a run config, if you look at the object here, the run config object from OpenAI, it has a list of different things, from a workflow name, trace ID, group ID, handoff input guardrails. So when you run, so whenever you define a run config, you're defining a configuration for a specific run, as the name says. So you choose what workflow name it corresponds to, what trace ID it should report to. So let's say tracing will be coming to in a while, so I think then it becomes a bit more clear. But essentially, it's a container object which will hold all the configuration for a given run. So anything you can identify the run with, for example, let's say handoff patterns, any guardrails you have to put for this specific run. So there are two paradigms, an agent paradigm and a run paradigm. So when you run agent, you can configure settings on an agent level also. This agent has specific guardrails, agent has specific handoffs or whatever. You can also do the run level. For this specific run, I want these settings. Essentially a settings object, basically. So config object settings object. You can define some, like what is the workflow name, for example. And all of these things will be captured in the dashboard later on, where we'll come to in a while. So it's just a settings object for now. Okay, cool. So let's try running this example ourselves. I would encourage all of you to do it, because then you will see how the system actually works. So, but before that, like let's look at what the system actually is like. So the request is this. So our request in the demo workflow is that I want to create a Python data processing system that reads CSV from a file, performs data cleaning, calculates summaries, exports result to a JSON format, and includes error handling, right? And the prompt is that system should be modular and well documented. So I want this to be a prompt to my coding agent, right? And our coding agent has a reviewer, a coder, and a planner. So now I'm feeding this into our system, and I'm doing that how? Using the runner.run object, right? So if I scroll down here, in the main you'll see I'm calling a run. Yeah, away demo function has just come in here. Sorry, 1 second. Where is the demo workflow here? So here you can see I'm running this. I'm calling the run multi system function, which we defined earlier. And all it does is it defines a run config, creates a triage agent, and then calls the run on this, which you saw earlier. And now what run.run does is it runs the whole loop in itself. So you don't have to worry about adding the loop yourself, adding the exit conditions. So inside the .run function, I'll tell you what it generally looks like. So inside the .run, it does a lot of heavy lifting for you. So all you do in the run is you just define a starting agent, right? In the .run function, you define a starting agent. And inside the function what OpenAI has implemented, it will start with this, get a response back, perform any tool calls, transfer to any other agent, get the response back, and run this in a loop until there's no more tool calls left. So whatever loop we saw earlier, all that is encapsulated into the run.run operation. So if you go into the run, if you are curious later on, you can go into the run, and this will show you exactly how the loops look like. So like you can see, this is the agent is invoked with the given input. If there's a final output, it returns. The loop terminates. If there's a function call, it runs the loop again. For example, so you can look at the run function yourself. Interesting if you want to know. You will find the same loop that we talked about earlier. It's part of this loop here. So that is the abstraction that you don't have to worry about anymore. But anyways, so let me run this file now. 1 second, let me save this. I'm not sure what I changed here, but let me just check if I changed something which might break it. But I would encourage all of you to run this system. So do Python multi-agent system.py, and you will see that your coding agent. You can also change the prompt if you want. You don't have to build the same CSV thing that I'm building. You can look at the prompt. You can choose whatever prompt you want. Like treat this as your own cursor. Give it any prompt you want. If you want to make a website, write the end of the prompt, and see how it actually builds, and see if you can evaluate if it's doing a good job at it or not. I think that will be a good exercise. Like everybody choose their own prompts, choose what you want to build, modify the prompt, and then run the system to see how it works. So I'll quickly give you 5 minutes, and I'll also run this myself, Abhi. Okay, this is fine. So I will cd into my multi-agent thing. I'll do a Python. The important thing to do is to install all the dependencies, because you might not have OpenAI agents installed in your system. So I'll source it. I'll do a UV pip install. I'll just see. Yep. It should be. I hope. It's not? Okay, I'll give you another key now. 1 second. This darn API key, bro. I don't know, with some magic it just invalidates after the first try. No, it's going on. Perfect. Okay, I've added another key now. Try if that works or not. I hope it does. Do the same just as it before. Okay, I'll try it here as well. So I will install all of my dependencies. Install. Perfect. And now I can, one second, let's get rid of this for now. I'll run a Python multi-agent. So I'm running this demo now. Complex data processing system. This is the request that I sent to it. I think you can choose your own prompt. I think that's the best to do. Don't just do the CSV stuff. Change into whatever you want to do, like whatever system you want to build.
I have a question if you go ahead.
Yeah, go on.
So, for example, like back to the original objective you gave of us, making your own agent.
Yeah.
So, when I showed you, I had added the instructions in the triage agent.
Okay.
Whereas, from what I can see, that triage is only the first agent. Then after, like the control never comes back to triage because I can see the handoff never. Nothing is ever handed off to the triage.
Correct. You're right. It just like.
So
That's just there for like reference. You don't have to add that. You can remove the triage altogether.
okay.
I just added it as a way to like showcase a pattern. Sometimes things work like this. You have a triage which routes your request to the right thing.
What I was going to ask is, so whatever context, like instructions we're setting for the triage agent,
Mm-hmm.
you are the triage agent, you're supposed to X, Y, Z. So since I had added the instructions there, those are not going to be passed on to the other agents, right?
No. Okay. It's a very, very good question. I'll tell you exactly what is being transferred. I think somebody else also asked me the same question. So the question here is like for everyone else, what's your name? So Varun is asking that, okay, what exactly is being passed from one agent to the other agent? So I think it's a good question to answer. Others might have the same doubt as well. I just a very small duster with me, but never mind.
Wait, I'm fine.
Okay, so the question is this. So you have a planner agent, for example, and you have a coder agent, for example. Let's take these two examples for now. Right? And then the planner has its own tasks. It has like a whole list of things to plan, whatever. And then when it knows it has planned it perfectly, it has to then call coder agent, right? But then how does it decide what to send to the coder agent? Right? So like what exactly is being sent and how does that mechanism happen? Any answers to that? Like how does that happen?
You have to give some endpoint that terminate your session only when you get.
No endpoint. Like what I'm asking is, okay, planner knows that, okay, I have planned this out. Or maybe even better, just think of it as like he was pointing out earlier, let's think of it as a news collector. So this guy searches for news online, gets a list of headlines. Another agent tries to summarize news, for example, right? And now it knows that, okay, once I've done some web research, whatever I've done, I got a list of n number of links, right? And now I have to summarize it, so I'll call the next agent here. But then what does it call it with? Like how does this data, whatever data is here, gets to the other? That's your question, right? Like what is being decided on what to pass? That's what you asked, right?
So why I asked that was because in the first exercise we had those roles, right?
Correct.
System, we had user. So here the way it was at that time is system, user, and then there's a loop of assistant, user, assistant.
Correct.
And at every LLM call, this entire
You're right.
this turn of messages, that entire thing gets passed. So the way I was imagining it for every agent, these instructions are the system call. So here also, is that being separated out somehow?
Yes, I'll tell you exactly how it works. So what happens is this. Okay, let's look at this example again. News agent has its own system prompt, which is this set of instruction that it has to search through things. It gets some response back. So there's let's look at the messages array here. First was the role system. Second was the role user, which said, okay, I need my news. The third was the role assistant, where it, like, maybe there were some tool calls also, let's simplify it. It made some tool calls, and then ultimately there's a role assistant, which has a list of all the news articles. And now there's a role tool which is transferred to summarizer agent, correct? And now what will happen here is that when this tool call happens, right, it'll be like a transfer to agent function, and then the parameters will be an agent name, comma, a message to pass, right? And the LLM will decide what message to pass here. So LLM will know that I have a summarizer agent in the next step. I need to give it all the articles I have and any other context it wants. So LLM will generate this parameter and it will pass it to the next agent. And by passing, I mean what will happen is, now let's look at the summarizer. For summarizer, what will happen is when the summarizer is called, it will already have a system prompt because it is also defined with the system prompt itself. So when you make the call, when the summarizer makes the API call to the model, it will already have a role system which has its own system prompt. It will then have a role user, which will be this message here. So this message from the assistant, this assistant becomes a user message for this agent. And now this will do its own stuff, tool calling, whatever.
Since that message is generated by the LLM during that tool call, it is smart enough to separate out the original system.
Exactly. So like this LLM is smart enough to know what exact message should I pass to the next one which has all the context. And if it's not doing that, then it's your prompting problem. You should tell the agent, okay, you need to call the summarizer agent. I think it's smart enough to figure that out. For example, let's say if it knows that this agent is summarizer agent, then it should know that, okay, I need to provide links, otherwise how will it summarize in the first place? So it knows by itself what parameters to pass here, and those parameters become a user message for the next agent. That's how the flow works. That's the internal working of how it works. Cool, I think a great question. I think what I can do now is, let's say, I think, did all of you get a chance to run it? Yeah.
Is there a possibility that one of the agent miss some of the information which need to be passed?
100%. There's a strong possibility. Very good question as well. So what you'll do then is a very, a thing which we follow in production systems as well. It's called structured outputs. So what we usually do is this. You can force an LLM to respond in a certain way. For example, what you do is, are people familiar with pedantic here? Pedantic or, so like, it doesn't matter. What you do is you define a class. Let's say you define a class called request or whatever you want, right? And you define certain set of parameters. And then you can force the LLM to respond as a JSON which corresponds to this class. For example, I'll tell you how exactly it works. Let's say I have a news summarizer agent, correct? And let's say there could be a case where it forgets to pass news links to the other agent. But what if I tell this agent that you have to always respond in this format, and one of the parameters here is the news links. It's an array of strings, for example. So now whenever this agent responds, it will always construct an object like this by default. It can never not produce it. So OpenAI has a structured outputs feature. You can look at it up in the docs. So what OpenAI does in the background is that whenever an LLM call is made, it looks at the response. It validates if it's the same class or not. If it is not the same class, it does another call. Ultimately, you will definitely for sure get an object like this. So you can force that an LLM always has a links object, which is not an empty string or not an empty list, for example. So there's some control you can enforce on it, but that's the limit of what you can do. If an LLM decides not to give you the list, then it's up to you. Then you have to either change the prompt or make this typing a bit more stronger. So it's a combination of very nice prompts, good model, and structured outputs, which can make your system a bit more robust than it is usually. So that's something you should check out, I think.
So in your code, you have used only one LLM model.
Yeah.
So I am sure definitely there would be some kind of gap of the request. Right?
Gap of the request didn't get you.
Like maybe the limit can exhaust in one of the models.
It can, but it usually doesn't happen so much, because if you have a huge run like that, then you should break it up into other agents then, probably. Like if a single agent is having a huge context like problem, then probably it's the work of two agents. Or if you don't do that, like there's another way to do it, is that you can summarize previous conversations. So what you can do is have some more control over your messages. And what you can do is, let's say, when you're running this agent, it's getting the context of all previous conversations, right? It's getting all the messages array. You can try to truncate this a bit. Either like, let's say, delete some of the older messages, or summarize some older message into a smaller message. So that way you can keep doing it. But that is only possible if you write your own agent loop, because then you can control what messages are passed to the agent. In frameworks, you don't really have that much control over the messages. I think some agent frameworks might allow it. I'm not super sure. But for that, you have to add some hooks. So like before tool call happens, summarize the context. So those are a bit more advanced concepts, but it's possible to do it. Definitely possible in a custom setup, but probably frameworks also allow it. Fallback model? What do you mean? No, it won't really matter, right? Because if your context is huge, if your context is 2 million tokens, doesn't matter what model you use, right? It will still be the same 2 million context gets passed into every model. So it's not a model problem, it's a context problem. Because I said model is stateless. Model doesn't store any state, doesn't have any past messages. And every API call you send the whole list of barrage of messages that you have. So if that is a huge number now, you have to truncate that, otherwise it won't work with any model. That is the idea. Some models have a higher context window, it might still work for them, but like for smaller, you have to like always, it's best practice to just keep truncating if you have a huge task, or break it up into smaller agents, which have their own independent models. That's usually how it is. Okay, cool. Did everybody get a chance to run this agent now? Yeah. One agent can be called by different. Yeah, 100%, 100%. As I said, like it's a stateless thing. Yeah. I'll tell you. So ultimately, what you're defining as an agent is just one instance of an agent, right? It's not really. The thing to keep in mind is it's not stateful in the sense that there is no memory of an agent right now. Like an agent is just a class you define. It's a set of prompts and tools. So when you call runner on a single agent name, it's a completely different API call. Like everything you do is a single API call ultimately, and that API call has all your context, it has all of your messages. So if I call, let's say, 3 runners parallelly, all of them make 3 different API calls with their own context. So your instance is just the same. You're making different objects of a same class. You can think of it that way. So my agent class is this planner agent class. I'm making different instances of this class. I'm running them in different patterns. All of them get their own, let's say, list of messages to pass through. That's the idea. So go on.
Yeah, I ran the.
Okay.
I'm getting the output as the code and this one, but
Okay.
in the log, that the final result that is logging,
Mm-hmm.
it looks like it's the result of the first, what do you call, the planner agent, not the final trial. It's the trial.
What is the last message you see?
The final result is basically it's like designing and scaffold complete and it's ready for implementation.
Exactly. So this is a really good point. So sometimes you might see. Okay. So usually.
It did all those things, but it's the result that it fetched is the first planner agent's output.
It created the files for you?
It created the files. It's not creating the files. No, for me it created the files,
Okay.
created the code, but I think the result is the one because that is the output of that call.
Okay.
Planner agent is the first agent's output.
Okay. I think he's something to say for you.
That message that you have, if you go to the top, maybe so because I'm in the same position at you, but I can see that I have reviewed, so I can see it's the reviewer agent which is supposed to be one of the last. So that might be happening in your case when it's reading the last part and not the top.
Yeah, reviewer will be the last one which says, okay, I reviewed the code, looks good to me, something like that. But like, what are the problems that you're facing? I think I'll be there in a while. Arnav, you mentioned, right? Like you mentioned it didn't work for you? Are you running it again? Okay. So like sometimes what happens is it working for you guys? Okay, perfect. I'll just okay, 1 second. Yeah. What happened? Yeah, I think sometimes what will happen is this. I'll tell you the common problems is what I'm seeing here. No, I think what the problem which many of you are seeing right now is that it outputs a plan but doesn't really code anything, right? So I'll tell you why. So the thing is, like when you define agents, most of the time agents wait for your approval. Let's say they say, okay, I made a plan, do you agree or not? But our system is a bit different. Ours should be an autonomous system. It should hand it off by itself. So if it were an agent in isolation, it would have worked perfectly because it would have asked for user input, you would have said yes, go ahead, and then it would have done the rest of the stuff. So here what you'll see is I have a prompt here which says, if you go to the planner, let's say 1 second. So these are which problems you face when building systems like these. The prompt needs to be tweaked again and again. Tell it, like for example, if you look at the planner prompt, 1 second. If you look here, try agent, planner agent. I have an important message here. It says you are working autonomously. You're not allowed to ask the user for any information or consent. That's it I've written, right? So this is maybe not good enough. So I add this because I wanted the system to work by itself, but it's not doing. So what I'll recommend you to do is, whoever is facing this problem, add to this prompt, write something which will make it work better. You can imagine what that prompt will be like. Let's say if you're facing this problem, it's not trying to code, write a prompt which will make it not wait for approval and just send it off directly to whatever it wants to do. So try tweaking this prompt a bit, because everything I said, the system is built on prompts and tools. That's all there is, really. So if the only way to debug, only way to fix this is to think hard about the prompt. If you can add something here, add it. If you're having doubts about it, ask O3, ask any of the model, tell the, sometimes what I do usually is that if I have a very complex problem at hand, this is a very simple problem to solve. But if I have a very complex problem, if I'm not seeing the agent performing the way I want it to, I ask O3 or I ask a bigger model, I tell it, okay, this is my prompt, this is the behavior I want. This prompt is not doing that. Find the discrepancies and fix them. So O3 will read your prompt and will try to fix the prompt. That's the idea.
So I just added directly implement the plan create. And created the file.
Yeah.
File somewhere else, but you created.
Yeah, exactly. So like that's all it is. Like just add some tweaks to the prompt, see if that works or doesn't work ultimately. But then it'll go on. Okay, try it out a bit. Oh yeah, okay, 1 second. Anybody else got the Composio's keys to work?
No. Bro, so he's fail कैसे हो गया? What the fuck? इसमें current.py वाला account है, just log in the platform, create a new key. Wait.
Stupidest problem to have.
What the fuck is
Can you check some of the real-time API calling? What is the tools we have in Composio?
I didn't understand what you mean.
Some of the APIs we
Yeah.
can call using what is the tools we have.
Oh, yeah, that's it. You can go to app.composio.dev.
do an auth flow, you can authorize Composio to use the user sheets, and then all of your agents by default will then use Composio to get the credentials and perform on the fly. So you get a access token when it needs an access token, performs the action, then it expires it on. So Composio gives you not just the managed tools, but also the auth then to go. So you can explore Composio.dev to find all the list of apps there. You have a bunch of different apps you can use, and you can make the agent way more powerful than it is usually. So you can integrate with n number of apps, perform n number of tools. Let's say with web search, for example, if you want to integrate web search into your coder agent, because that's something that Cursor also does. That is also one of the challenges I had for people. So if you're building an agent system yourself, you want to make it more powerful, you want to add web search. You don't have to write the web search yourself, you can just use filecrawl or search API from Composio. Just go to Composio.dev, register your filecrawl thing, give it your credentials or API key, and then you can just call filecrawl action from your agent. You just add the filecrawl action to your API, sorry, agent as well. So it just gives you access to a whole bunch of different tools to work with.
So these are workflows that you all have implemented, or what is it?
These are tools. So like simple Python functions. So
Jay,
you see?
I'll answer that question.
Okay, perfect.
Can you check OpenAI from this?
I'm sorry, what was the question?
So these are basically workflows, or these are actually?
So there are different types of tools. Some are actually workflows. For example, the firepower. You give that tool some UI, so it performs the whole work for you, like spawning a browser, transcribing the data from the website, and creating in a, like some whatever format you require. So these are like workflow tools, and some are like direct API work. For example, let's say you want to fetch your email. It's a simple fetch email, inject it off, and you get to this query. Is there other issue than the OpenAI key? Like just open key. Okay, I'm trying to fix that. We are trying to fix it. Wait. Oh, why is this? Oh wait, can you reload?
I'm adding new keys.
You haven't added them yet. The hash latest.
I removed them.
Did you add Karthike's?
Those are not valid.
Bro, just create a new one. I give you the log. Bro,
I
get the login
Try
access.
this. Try this, Jayesh.
You did not submit a. I
This is
didn't
on my
create it.
personal account, so it should be there.
Okay. I'll add both of these keys again. So now the just will have two new keys. Try it out. I hope this time it works. Let's check now. But other than any problems like people who are already done it, I think the one theme which I found for people who ran this was that it's hard to understand what agent did what exactly. You just get a result in the end, which is like a bunch of files that created. But you're not sure that if the agent that you wanted to create it, or how it created it, what tools were called, what was the internal system like, right? And if you imagine like a system which has 5 or 6 different agents, a way more complex system than this maybe, it will be very hard for you to trace if something goes wrong. Let's look at a use case here. With the files that we created right now, if there were some faulty files here, what do you fix? Do you fix the coder? Do you fix the planner? Do you fix the reviewer? Maybe the plan was wrong. Maybe the plan did not cover all the use cases properly. Maybe the reviewer was faulty. You didn't review it properly. That's why it failed. Or maybe the coder was faulty. It could be a combination of any of these things, right? So what is lacking here is a bit of clarity and observance into how your system is actually working, right? So maybe once you run it, like I think I'll give you like 2 more minutes to do it. Like there's a new API key. Try running the example yourself because I want you to see for yourself how this is going on.
Yes, we have figured out the issue.
The problem is when we publish this gist, right? The crawler detected an OpenAPI release since it's like public.
It's a private gist.
No, private gist is crawled.
Really?
Yeah.
GitHub, in GitHub.
I thought the private is always private.
GitHub has this thing.
In terms and conditions, they say that. Let's see how to.
Basically,
So we'll come to that. The fourth module, state management, is about that. So how do you make an agent remember across multiple runs? So you wanted to have some previous context, either a summary of the previous context or some entire context itself. So all these things will come into the stateful management. So that's where it is. But okay, like once this is solved, let's just move on with the project because hopefully the next module will work once I figure out the deletion thing. So as I said, like the problem that we saw here was that okay, the files were created, right? So I'll just come here again. So I get this folder created, like people who ran this will see something like this. You'll have a data processing folder and it'll have all the files which were created by the agent. But now, as you said, like I have no idea who created this agent because if I look at the terminal now, all I will see is a final result and a summary. The summary is that the code is well structured, implements this thing well. So this is an output of a reviewer agent, which reviewed the agent. But I'm not sure how many turns did the coder take, what files did it open or not. Zero visibility into that. So what you want to do in a production system is you want to add some tracing and some observability into it. And I'll quickly take some time to make you understand what tracing really is. For that, we'll go into the next module here. Tracing multi-agent systems, okay? And okay, so the idea here is that it's exactly the same code as before. There's not much changes that are happening here. All that will change is one single line. So you can see there's a planner agent, same as before. There's a coder, there's a reviewer agent. I just copied the whole thing from the previous file and added one line here. And what changes here is when you run the coder, so here, you will see I added a new line which is with trace. That's all you need, right? So ultimately what tracing is this. I'll quickly show you a file, 1 second. I'm not sure if I can. Does everybody have an OpenAI account here? Correct? So I want you to go to platform.openai.com and I'll quickly show you this. This is the keys. I don't want to show you the keys, but shit, sorry. I'm not in the right project. I think I'm in the right Composio. What account is this? This is an Indian account. So the best way to do it is I'll run this myself. Done. Copy. Done. Okay. Let's go to dashboard again. Oh, shit, sorry. Dashboard.
Can everyone see here? If it's okay if I write URL here? I'll write in big letters, don't worry.
Why the dashboard is not coming up? What the fuck? Something really wrong. Can you open the dashboard? Like, is anybody able to open the dashboard on their OpenAI account? Can you try? Can you see a traces on the left? Do you see a traces option?
I don't see traces.
1 second.
Logs के अंदर there's a traces वाला.
Exactly. Yeah. So look at the logs. Yeah. So I think they changed a bit overnight, probably. So earlier there was traces, but now there's logs. Never mind, the same thing, anyways. So here you will see traces. I'll quickly show you what a trace looks like. Then we'll talk about what traces actually are. Okay. So if I open any of these traces here, traces. So the idea here is that this is what it looks like. So I just ran some agents right now, correct, in the past. You see there's a triage agent, there's a planner, there's a coder. So here is what you'll see how everything works. Can you see in the back? Okay. So the idea is that, yeah, I think if this is clear, right? You can see everything. Okay. I'll just zoom in a bit more. Hold on. So here what you'll see is this is a complete trace of what happened, what was the first agent to work with, how much time it took, everything else. If you want to go into details, you click onto any of these. For example, what did the parent do exactly? I can go here, there's a post responses, right? So I click on this, it made a post request to the responses endpoint. And when you click on that specific endpoint, let's say, you'll see something like this. when was it created, what is the ID, what is the model that was used, okay, and what is the functions that were available to this specific model. So everything you did will be visible here. There will be input instructions, there will be input here, this was the input to the planner, and if you scroll all the way down, you'll find an output as well. So the output was a function called transfer to coder, see, I told you. So when the handoff was coder, it called a transfer to coder function in the end. So you only see this now because you added the tracing. So that one single line with trace is a helper function provided by the Agent SDK as well. What it does is it tracks every single activity that your whole system performs. If it hands over to some other agent, it tracks that. It tracks what functions were called, for example. Everything happens by itself here. So how this helps is that you can see here there's a handoff to coder. See, there's a handoff to coder. And then you can see coder agent starts here. So all the pieces are from coder agent itself. So the coder created a responses. It made a call to the OpenAI API, got a response back. So you will see if I scroll all the way down, there'll be some code probably. It calls, one second, output is, file tool, create file. It tries to create a new file. So it calls one tool here. And the next thing you see is a file tool create file. Right? So it created a file first. So this was the tool execution. You can see the output of the tool. It was some error happened because there was no such file directory, whatever. But like the point is that you can always find everything that happened with your system using the traces here. So everything is all here. Like then finally, it got to a point where it started writing some code. So if I go here, let's say, if I scroll all the way down, you can see it wrote some text here. So main entry point data, there's some from Python code written here, right? And then finally it called the run Python code function to try to test everything is working all right or not, right? So that was run Python code. So what I mean ultimately is that, oh yeah, shit, no man, sorry. My bad. Now the point was that now with traces, I have a bit more visibility. It's not perfect, but it gets me some idea of at least if my system is working properly, what the inputs to every response were, what is the output, when did the transfer happen, was the transfer right or not. And what you can also do is you can imagine if anybody takes a long time, it will show up here as a red bar. So this is the duration it took for your API call to be complete. All of these are there. So if there's a huge duration, there might be something wrong with the API call, or maybe you exceeded your quota, maybe the tool call that you have was a bit faulty. And if you find too many traces here, and you see the agent is repeating itself, or having like multiple repetitive steps, there might be something wrong with your prompt. So that you can then investigate. The best thing to do is read all these traces, read all the input and output, see if there's some redundancy there. Is the agent doing stupid things? Is it not supposed to do something which it is doing? So all of these things will become clear once you look at the traces here. But otherwise, everything is just a black box to you. It just gives you one final output, right? That is the idea. Yeah. You can export, no, you can't do it right now. Traces can't be exported. So Langsmith can do it. So like the thing I had in mind was for you to implement a Langsmith implementation. So what I have in the code right now, if you look at the reference, is a take home exercise. In the code you have OpenAI tracing, which is like the standard OpenAI tracing. What I want to do is I look at Langsmith. Langsmith is actually a really nice one, a really nice tool to do tracing. It has alerts, everything else. So a take home exercise would be try implementing Langsmith with the same agent system. Langsmith gives you a lot of control. There's a programmatic access also. You can export this to your own dashboards, whatever. And there's alerts as well. So for example, if you find that your system is already in production and it ran through multiple loops, like it exceeded 50 loops, you send an alert to the team that something is failing somewhere, you need to investigate. Maybe you need to invalidate a key, for example. So that's an advanced thing. So you should try Langsmith, implement Langsmith. Yeah. Yeah, Langsmith has a hosted version as well. You can host it in on-prem as well. That is an option. It's not. It's not open source, but there's an enterprise plan that you can host it yourself. So Langsmith is nice. Traces comes with OpenAI as the simplest thing to use. Doesn't require a lot of setup, super easy. Even Langsmith doesn't require a lot of setup. It just requires 2-3 environment variables to set. But that's your exercise. You'll figure out how that works. But the idea is that any tracing tool would work in this situation to help you understand how the agent flow is happening. But in addition to that, like, is everybody clear with tracing, what tracing is? I'll just like gloss over the terminology a bit more. So this is a trace. All of these are spans. So a single span is one instance of a trace. So okay, like for the, this is a span. A span was okay, there was a post response. This is another post response. So all of this is part of a trace. Doesn't really matter if somebody asks you, will know what it is, but like traces and spans are just this.
Kind of trace.
Yeah, maybe. I'm not super familiar with that, my bad. Yeah. But it sounds right. Yes.
Is the tracing enabled by default? Because we were all just running the second exercise and does not have the big traces line, but I still can see it on my console.
Yeah, I think OpenAI Agent SDK does that. Maybe it does that. I'm not super sure about it. But the behavior should not see it if you don't add it. but maybe this changed something. I'm not super clear about the idea. Yeah, but maybe it's there. Maybe it's there, maybe it's not. But the idea is that you can use it with any SDK. So agent SDK is one, maybe it has it inbuilt. But let's say if you use your own, like even in the toy example, you can add the with trace in the toy example also. So when you're running any loop, you can just add with trace and, at the toy it won't really work because it doesn't know when to track. But in most frameworks it will work with you. Like you can use like this with LangGraph, you can use with trace with any other.
Why wouldn't it work on the toy one? I mean, there'd just be
Because
one request, right?
it will work. You need some manual intervention to tell it what to log. So for example, let's say when you run this thing yourself.
It's not using the agent SDK in that case.
Exactly. That's why it might not work. Because it won't know what function call to log, what not to log. So you have to configure it a bit. This is very painless. You can just add bit trace. With other things, you have to configure it yourself a bit more.
वो Composio के account से OpenAI keys create करके student को भेज दोगे?
मुझे DM करना.
Okay.
Don't put it on GitHub, nothing.
Oh, you can make your own API key, na? It works for any API key.
No, my org is new, so it'll take 15-20 minutes to warm up.
Oh. I understand.
But good, we were crossed by security.
I'll just give it to you from my API. Hold on. Let's see. I'll do it from my laptop. I know. I've seen that before. Not a dull day. Not a single dull day in this life.
But it's our bad. They send an email also.
Who?
OpenAI people.
Oh shit.
They send an email saying that your key has been leaked. So we might have gotten like 10 emails by now.
Okay, don't use this one which I sent you. Okay, use this one. Use the RSV wala. I sent you on Slack. Yeah, great. Okay, I'll come back. Sorry for the delay. But yeah, so this is tracing. Multiple tools to use, but it gives you visibility into some stuff. But that's only part of the problem, right? What I want to tell you next is lifecycle management also. And I'll tell you what that means. So I'll remove this file from here for now. But so far, any questions on tracing, what it is, how it works, and why it is important? I think everybody realizes why it's important.
So one thing I wanted to understand is, like from what I saw, I'm not really sure if I can do this at a request response level. Like I would have a specific call, I want to trace it anywhere. Is that?
It does everything. Every single call that LLM makes is tracked here. So what did the LLM do? What message it transferred? What tool it called? What was the response to the tool? Every single call is tracked. That's the whole point of tracing, because I want to know exactly what's happening. Maybe I want to identify what the bottlenecks were, what tool call took the most time, what API call took the most time, for example. Is it hallucinating? Is it like checking in a loop or not? All of those things will become clear once you look at the trace.
Can we customize what it shows?
You can do that. Like this is a very basic trace. If you look at the trace function here, I think this will become clear if you do this. If I come here, you'll see, hold on. Oh, not here, there's this thing called, there's a config file as well. This is a config object for tracing. You can set that for yourself. Keep what you want to trace, additional stuff. It's there for ADK. I'm not super sure about Agent SDK, but there should be something around similar lines for Agent SDK as well.
So because this has been a pain point with a lot of frameworks. Like for example with Crew, right, this has been a main pain point. I'm not sure.
Tracing?
Yeah.
What do you mean? Lack of tracing.
Lack of tracing.
Exactly, yeah, that's why I like ADK because, ADK and Agents SDK both, because very painless to do tracing here. So you know exactly what's going on. I'll come to the next step now. It will become a bit more clear, why observability is a bit improved on these two, SDKs. So in addition to tracing, we saw how it worked, but I need some more control. I need more control on what tools are called, what agents are called, and how these things work. And for that, we have something called lifecycle management. So a lifecycle management is, a lot of tasks. One thing I'm pretty sure of is like have some muscles by the end of the workshop. Cleaning boards. It's a humbling experience. Okay, never mind. Oh yeah. Whoa, where's the pen? I kept it somewhere on the table. Yeah, perfect. Thank you.
Color? Choice of color.
Green. I prefer all green. Okay, never mind. So getting back, so trace is already there. I want some more control, and that's what lifecycle system will give you. What I mean by lifecycle management is that throughout the execution, I want controls over what happens when an agent executes, when it starts executing, when it ends executing, before it calls any tool, after it calls any tools. I want to inject code or certain validation there. So what I mean is, let's say an agent is there, right? It decides to call, let's say, the create file tool, right? There's a create file tool, and let's say there's a web search tool, for example. I want to know that before it calls this tool, or before there's also transfer to coder, right? Like transfer whatever handoff thing is there. When I run this in my system right now, I want to see in the logs itself that it's transferring handoff to something. I don't want to go back to the tracing to see if it hands off something to the other thing. So how do I do a system like, how do I build a system like this? So I wanted before any function is called, I see it in the logs myself. There's additional logging which happens at every step. And maybe I want some validation as well. Let's say before it hands off to the coder, as you said, like sometimes agents might hallucinate, sometimes they might not perform the way you want them to perform. And I'll give you a use case why. Let's say the planner was an agent, right? It maybe didn't make a plan at all. It hallucinated something. It said, I made a plan. And then it tries to call a coder agent, right? So how does it do it? It calls the transfer to agent wala function, correct? And what you have observed as an experienced AI engineer is that when it reaches, you look at the trace. You look at the trace and, okay, the output was that you didn't get a file. So you go to trace, you figure out what the problem is. You see that when the transfer is happening, there is no plan. And it's sending an empty plan to the coder, so coder is fucking up. Sorry. So what's happening is, I want to add some validation here. I want to make the system perform well. What do you do in this situation? It's an open question here. So you are given a situation like this. You are a very experienced AI developer. You find that your planner agent is supposed to work very well. The prompt is great, impeccable. In half of the cases, it's giving an empty plan to the coder. Coder is then messing it up. And there's some problem here. How do you fix a problem like this? Validation in what sense? What do you validate? You have to check if the plan exists at all. That's I make it simple. You have to check if a plan exists at all, right? How do you do this then? Yeah, that's a big enough in itself. Any ideas? Any ideas on how you'll do it? Like just think randomly. What can you do? It can be a combination of different systems, combination of function calls, combination of validation logics. Because every time you're building an agentic system, it's very important to pair deterministic logic with agents. You can't let the agents lose all by themselves. You have to add checks and balances at every step of the way so that it doesn't really mess it up in the bigger picture later on.
Just a simple test.
What would a test look like?
Let's take something out of the test plan, simple liner and testing out the use case. Samples.
Okay.
Some request is like a test case.
Coder agent can go back to planner if the request is in.
That is also a nice point. You can tell the coder if there's no plan, just go back to the planner. That's a valid answer. That's one. But I reduce the loops. I don't want to like make it even go to the coder in the first place. Because then it'll cost me some money, no? I'll send request to Cloudforce and every time there's an empty response. What's the point? Save money. So what do you do? I'll tell you what, I'll give you an example, I'll give you an idea. What I'll do is I'll ask the planner to always write the plan to a file, for example. Okay? Done. And once it writes it to the file, what I'll do next is when this function is called, transfer to coder, I will add a hook here. I will add a function which runs before any function call is run. I'll check if the function call is transferred to coder. And once I find that, I will look into this file. Okay, and I will make an LM call. Maybe I'll do some semantic checking as well. I'll check if plan is in the text or whatever random checks you want to make. If there is no file or if the file is empty, I don't pass. I don't let this function go through. And I send a message back to the planner that you didn't write a plan, right? So that is the idea. Make it write to a file and then before this is done, add this check. So that's just one example of what a lifecycle management hook would look like. This gives you some control. It gives you some validation position. You can, before any function call is made, you can check if the function call is even there to be made or not. One example, there are many other examples. For example, let's say before create file is called, you should make sure that the file system is registered, whether you have access to the file system. So you can add those checks at this step, for example. And maybe after you want to say file for create file, let's say. I want to add it after this is run, add another function to clean up the file, for example. We can add this as a post step. So all these things help you manage the lifecycle better. But in this context, what I want is more observability. I want to know when a function is called. I want to log some things before a function is called, log some things after a function is called. And so all of these use cases, observability, validation, extra tracking, those require lifecycle hooks. And those are an advanced concept that you should start implementing once you face problems like this in production. Things are not working like you want them to work. Even after tracing. Tracing won't help you. Tracing will just tell you that something is wrong, right? So what you do is then you do something like a hooks. So if you go into the hooks file, I want you to look at the hooks file and see what has changed here. So just like observe the file a bit, go through it yourself. So you'll find something interesting, which I want to talk about here. Take a moment to yourself, look at some stuff. What looks interesting? Handoff hooks, correct? Right, so OpenAI, I think I'll recommend you to go read the documentation later on. But just to start off with, OpenAI has a class called run hooks, which allows you to define a bunch of hooks. Hooks are just functions called at certain stages of your life cycle. That's what it is. So it gives you a list of hooks to call. So like the on handoff is one of the function parameters. There's on tool call, or I think on tool end, something like that. On tool end, on tool call, on agent end, on handoff. So if you go into this run hooks class, I'll just show it to you quickly. Run hooks base is there, and then it will tell you what exactly the functions available are. You can override these functions yourself. There's an on agent end, there's on handoff, there's on tool start, on tool end. These are all the functions available to you. So what I'm doing now in my class here in the hooks system is that I am extending this class, the run hooks, and I'm overwriting this function called on handoff. So this function will always be called by OpenAI whenever a handoff happens. You don't have to worry about it yourself. So what am I doing on a handoff? And a handoff has its own signature. The signature is fixed. You get a context object, which we'll talk about later on, and there's a from agent and to agent. So this is always called. So whenever this function is called, you always have these parameters yourself. The SDK gives those parameters to you. And now in this function, you can define what you do with these parameters. So all I'm doing is I'm just doing an extra logging here. I'm writing print handoff from ye to ye. Right? So I'm just doing that for my own sake. I can do multiple steps. I can do add validation here and add whatever I want. I can make an API call XYZ, whatever. Doesn't matter. For our context here, I'm just printing it here because I want to, when I run the system, I want to see the logs myself and see when the handoff is happening as a very basic rule. So I added this handoff here, and all I do to make this handoff, all I do to make this hook available to the runtime is I go to the runner.run function. So you can add these hooks at agent level also and at the run level also. Remember I told you there are two paradigms, agent paradigm, run paradigm. You can configure settings on an agent level or on a runtime level. So right now I'm doing it at a runtime level because I have multiple agents. I want that whenever this system is running across all agents, I want this hook to be applied, no matter what agent is running. So on a runtime level, I want this to happen. And for that, what I do is I do a runner.run. So if you come here, I'll just quickly show you. Where is it? My bad, guys. 1 second. Demo workflow. Run multi-system. There you go. So in the runner.run file, function, you will see there's a hooks parameter, and I'm passing the object which I created earlier, the class which I created, handoff hooks. So now by default, all the hooks inside it, like I only have on handoff. I can have a bunch of other handoffs, a bunch of other hooks as well. It could be tool and whatever XYZ. I'm adding those things here. All of those hooks will be applied when this system is running now. That is the idea. All that I have to do is this. Now I would encourage you to run this file as well. So what we'll do is we will come here and we'll try to run the hooks multi-agent system. So I'll come here. I will cd into my tracing, right? And then I'll do a Python hooks multi-system. So now let's see what the output looks like. So what we should see is print statements here whenever handoffs happen. So you can see there's a handoff from trash to planet. It came right now. So now it's a bit more visible to me even in the logs section. So that's what hooks are for. You can choose lifecycle cycles when what happens, for example. This is the thing. So whatever happens. Now I don't want to run this whole thing ourselves. But that's the idea. Okay, we're running short on time as well. So I think we might have to skip a few modules, but I'll gloss over them in a while. So far, any doubts? Any doubts on hooks? Doubts on tracing? Why it is important? Why you need it? And the powerfulness of hooks. So this is also the case with Google ADK. They also give you these lifecycle management tools. You can add functions before, after tool calls, before, after agents. And you know why to use them, where to use them. In many advanced cases, these will help you out in adding more logs, adding more validation. Once that is clear, I think we can move on to the state. Oh, maybe do they want a break here, or can we keep going?
You almost have 20 minutes.
Only 20 minutes he hai, like that's what I said. Yeah, so. Okay, cool. So I'll just quickly walk you through state management a bit, evaluation take-home exercise. Okay? I'll just talk about evaluation also very quickly. But now what I'll tell you is for state management, as you pointed out, what's your name? You asked for the state management, right? Prerna. Yeah, so Prerna asked, okay, if I have one run system, if I run a system once, let's say, if I run it again, if I do another run of it, there is no way it will remember what the past run was, right? Because let's say the whole run which I ran once, it will have the whole context of the whole messages. If I run it again at a separate time, those things are lost. They're not being tracked, right? But let's say what I want is I want the system to remember all these messages in a way, somehow. So what I do is I need to have a system which can track across different multiple agent runs some certain things. It could be, let's say, a summary. It could be, let's say, the whole context itself. It could be important points about something, for example. But then how do you make that happen? You make that happen to state management, right? So there are two things I want you to remember from here. I hate this, man. TGIF. Where is this? Okay, cool. So two things about state management which I want to make you understand. There's two ways to manage state. Okay, the first thing is you have something called a session object, and this is in context of the OpenAI Agents SDK. There will be more ideas in the future, I'll tell you. So the idea of a session object is that it could be different names in different frameworks, but I want you to know what the idea is. The idea is that it's a persistent memory in the cloud or wherever, which tracks your messages through a session ID. So you create a session object first, it gives you a session ID, and then when you run, let's say if I show you the code right now, one second, if I go back to my runner.run, shit, my bad. Oh, it's control F, no, sorry. Runner.run. Yeah, in here you can see there's a session parameter, a session parameter as well. So you can choose to pass a session to any run object. So this will persist across multiple runs. So once you define a session object, it comes with its own storage in the backend. Here it's the OpenAI's platform session, but you can imagine every other platform will have their own way of implementing it. But the idea is that when you run these systems, you can choose to tie everything back to a single session. So that every run will have context for that given session. So that's one way of doing it. So now your agent will remember everything from the past session also. That's a very simple way to do it. The other thing is that you can use something called context. So context is another object here, which is passed to every tool call you make, every hooks, every handoff, anything you do, a context object is passed as well. And this context object could be any class. So you can define a class that you want to define. Let's say it could be my project. So in our code, you'll see I have added something called, if I go here, let me just go up here. You'll find something called a project context. This is a class I have defined. You can define it any way you want, right? Don't look at the details right now. It'll be a bit of a pain to go through. But my point is you can define any class, which can have any set of parameters here, any functions, whatever you want, and you can make OpenAI pass this class around through all of your tool calls. So let's say when you remember looking at the on handoff hook, it had a context object as well, input. So any tool call you make, OpenAI will inject your context no matter what happens. So let's say if you're defining your own functions for your agent to use, in the function signature, you can always add a context, a runtime context, and OpenAI will inject that parameter whenever the tool runs. So what that enables you to do is that, let's say, when an agent is starting, when you start the agent, you can start it with some context object with some parameters. Let's say project context. Here you have like a project name, project requirements, whatever that the whole agent system needs to know, basically the context itself. You can pass that through this object here, and that will deterministically be passed through all these things. Because you can't rely on prompts. You can also do it through prompts, of course. You can imagine sending the whole details through prompt to every agent. But that's, for A, very problematic. You have to like inject this everywhere in every single prompt. Doesn't make sense at all. And second, it might not be deterministic. And what this context here is that it's not being passed to the LLM here. It's being passed to the tools and to the handoffs for you to use. For example, the LLM might not even need to know project name, requirements, everything else. This is just some operational context which you need for you to execute this whole system. Let's say what file names to use, XYZ, whatever. Not super sure what the details should be like. And that is the context object, right? It gets passed around through all the tool calls, everything else. So that's also a way to manage state. It can get a bit overwhelming, but I think I would recommend you to.
Is this same as the memory itself, or is it more like a here I can maintain the list of files it needs to be created, more of a metadata?
Metadata.
It's more of a metadata. It's
Yeah.
not the memory.
It is, okay. It's the memory.
If you want to save the state across multiple rounds of
Yeah.
the agent, should I use context or should I use session?
Very good question. I tell you, like, it's all a matter of naming. Personally, what I would do is I would just use, okay, so even in this context here, so forget about how we implemented it right now. A context, usually how we use context is as a deterministic way to pass operational data. So whenever an agent is running, let's say I want that, okay, I'll give you a very nice example from my own use case. So remember the browser agent I talked about, there's a browser agent which goes and creates accounts on Book My Show or whatever different website. I want that this agent always remembers what the browser session ID is. Let's say whichever browser it is using, it needs to know what the session ID is for the browser, right? So I always pass that ID in the context. This is static information. Every tool call will have that ID. I can use it to like clean up the session, start a session doesn't exist. Like operational information, right? So it just uses that. There's no persistent memory here. So forget about how I implemented this. This was for the sake of the workshop I did it. Didn't get time to explain so much. But the idea is it should be just this. A bunch of static information that is available throughout the whole tool execution. But for state management, for like storing session messages, all of those things, you should need a session object here. That is the idea.
So basically it's session plus context.
Yeah. And then what you usually do, go on.
And the context, the data of context, where does it get saved? Say session thing.
It's in runtime.
It's on runtime.
Runtime. It goes away after runtime.
Anytime the agent dies,
It goes away. Gone away.
from where it reads again.
It reads from where you start again. Let's say when you start an agent execution, you provide a context object, you define the object, you run it. That's where it defines. That's where the values come from. If it dies, all the data goes away. And then you start it again, you run the agent again, give it the same context object, it will take the object again.
So for your example, that the browser session ID.
Yeah.
So the browser, if the agent dies, there will be a new browser session ID.
Exactly. So what I do is I use hooks. What I do with the hooks is before an agent starts, I call a hook which creates the browser session, gets the ID, puts it into the context for that agent object, browser agent. Whenever the browser is alive, it uses that same session ID. When it dies, I call a hook which deletes the browser, removes the ID from the context. That's what happens, right? So it's all in the same run.
So it's basically the metadata or whatever which every tool call needs to know.
Exactly. Exactly.
We are just passing from one tool call to another.
Exactly. Deterministically passing some operational information that every tool call needs to know that you can use. It could be anything.
So, like in your case, like in Composio, that the agents that you run or the kind of agents that you had run in the past in your production, like what sort of things that you need to persist and you are usually useful. Like from this, though, we can save almost everything. Like every step that we have been doing, we can save it. Conversations we can save.
Yeah, I think ideally what would help is, let's say in this case, there's files created.
Like basically, I just want some use cases where this memory would be which turned out to be very useful.
I see. Like the browser agent already understood, right? Like that is very useful because what happens to the browser agent is that, okay, I'll tell you what a browser agent is. A browser agent will use a browser, right? And this browser is hosted remotely by something, let's say BrowserBase or whatever the company hosts it. When I run this agent, I need to have an active browser for it to use, correct? So what I do is I have a pre-hook which creates a session on BrowserBase, gets the ID from it, and then feeds this ID as a context to this agent. So that whenever the agent runs, it always knows what the session ID is because it needs to make calls to this browser, right? So this ID is part of the context, and this is a post hook which deletes the session after the agent is done. That is one example, very simple. You can have other examples, let's say in this context. Do you have any question?
What sort of information is there in that session?
The ID, the session ID right now, browser session ID. It could be the name of the agent, anything that will help you. So ultimately, like for example, in a coding agent, you can add requirements as a string.
Yes.
So agent will know that, okay, these are the requirements I always have to install anyways. So any tool call you make, let's say when you have a run Python function, right? Run Python code function. So before you run this Python code function, you make sure you always install all the requirements, for example. So these requirements are passed on as context. So every time you call the run Python code function, you install the requirements first and then you call the function. Otherwise, it might be a problem. Like you can't trust the LLM to remember all the requirements and all the right versions. It's not the best practice. Just pin the requirements, put it in the requirements file, the requirements text. You can make dictionary also, whatever you want. That's just another example. But the idea is that, okay, these objects that I'm defining are just exclusive to OpenAI. The concepts are general, but don't get stick with the name, session context. Yeah.
My question was not related to the name.
No, I'm just like in general. I'm not talking to you. Yeah.
Like basically the things that you are remembering, trying to remember and being used.
Yeah.
So I wanted some examples that would
makes sense. There are only two types of memory. One is the persistent memory which gets stored across messages agent runs. Other is the context which is.
In your case, do that persistence layer or wherever the memory stores, is it in the OpenAI SDK or
in my application, here I have both. I have a session which stores it in OpenAI's session, and in the context object, I've added my own functions which writes to a JSON file also. So you can also do that by yourself.
In that JSON, what things are usually very helpful, like which you...
All of these things that you see here, everything here is added to the file.
But after a while, the conversation history will go through...
Yeah, I mean, like, this was just for demonstration purposes. You can just remove the conversation history, just keep the requirements.
More towards that, like basically in production, or the things that have gone live or have been using for...
Depends on the use case. Like, I can't really think of a use case other than the browser agent because I have that. But like files created will be useful. Files created because files created is important because it doesn't let you call creation of files endlessly. So before it tries to create a new file, it will just see if the file already exists. Why should create a new file? You save one call there. So like smaller details like this, like again, it's an advanced use case. So you'll have to come up with some more. I don't know many more use cases to be honest. But like it'll come to you when you start using it. That okay, I need this context. So basically, two types of memory: persistent and runtime. Correct? And then a take-home exercise for this would be implement mem0 for your functions. And I think I don't have enough time, but I would recommend you go through this entire code here. You will see how this memory is being used. So ultimately, what happens is that an agent just gets more functions to use. So how does an agent even write new memory? How does an agent edit those memories? How does it happen by itself? So you have to give some tools to the agent, right? Because anything the agent does, you have to. Anything that the agent does, sorry, I thought you were asking something. Anything the agent does needs to have some functions to it, right? Otherwise, the agent can't really perform any actions. So if you want to persist some memory, you have to give some additional tools to this agent. For example, one tool could be, let's say, I'll just show you here. So if you look here, if you look at the agent here, let's say I'll scroll a bit more. Okay, look at this one here. So I've added 3 more functions here. One is check file exists, one is get project memory, and one is summarize session, right? So all I'm doing is I'm telling the agent now, if you look at the prompt, you will see I'm telling the agent, always check project memory first to understand what has been done. Use check file exists before planning to create files. Consider past conversations and planning, and summarize your planning session before handing off to another agent. Right, so I told it these things, but it can only do that once I give it the functions to do it. So what I do is every time you implement memory, you should also implement functions that interact with this memory. Otherwise, how does an agent do it? It should be all dynamic, right? Whenever agent feels this is something important to store, you should call this function, which then interacts with your memory layer and stores it in the memory layer. If it wants something, you should give it a function which you can use to get the memory in the first place. So all these are different functions. So when you look at tools like mem0 and other tools, all they do is they give you these functions by themselves. So the secret behind any of these mem0 and other tools is that first they have a persistent cloud storage, and the second is that they have functions like these which they add to your agent, which can read, write, or summarize whatever XYZ from this thing. But this is as simple as it gets. You can just implement something similar by your own way, doing stuff like this. This is not mem0. This is custom. This is my own function. If you look into the code yourself.
Not this, like I'm talking about in Composio.
Oh, generally speaking, I think I just use my own functions because it's easier. I think mem0 you can use, but I think for more advanced, I think like for us, good enough to use our own files. Like we just maintain, because they have very complex needs. Like I need to write to a certain file in a certain way. I need to have access to the memory myself. I don't want to go to mem0's dashboard to see where my files are. I just write to my own S3 storage, for example. So it depends on how you want to structure it. I think mem0 also has a hosted version now. I'm not super sure. But I'm just telling you how the internal looks like. Inside mem0, it's all the same. In this whole world, there's nothing complex in terms of AI, like this stuff. Like all mem0 is doing is having a memory layer, giving your agent 3 functions, which checks, writes, and summarizes, for example. That's all it does. Yeah, that's it, I think. 5 more minutes left, but I think I'll just, yeah, go on. Yeah, I'll do that now. So evaluation is the final step. I think the key thing to evaluation now is this. This is what I usually do myself. So yeah, so I define very simple thing like this. I define a list of JSON files, so JSON lines, where every object has a name, a prompt, and an outcome. Right? So the idea, expect outcome. So idea is this. You have an agent system, does something, you have tracing, everything else, perfect, state management, XYZ. I want to now see if it performs great for a given set of tasks. So like I have a golden data set. So whenever I release this to production, I need to make sure that these 4 tasks are always completed very well. Otherwise, something is wrong with my prompt, something is wrong with my tools. So before I make any changes to my prompt, I make sure that it always performs the way I need to perform. Very simple, no fancy framework needed. Create a JSON file like this, add your prompt to that name, like, okay, for this is the prompt, and for this prompt, this is an expected outcome for this prompt, for example, right? And now what you do is, you run your agent. I'll just give you the very brief, I won't show you the code right now, you can look at it after on. So you run the agent with this given prompt. So you read this file, you go to every line, you take the prompt out, give this prompt to agent system, get the response back, and then have an LLM as a judge. Have another LLM, make an API call to that LLM, say, this is the expected outcome which I got, this is the outcome I got from the agent, this is my expected outcome. Are these things similar? If they're not same, then something's wrong with your agent. As simple as that. So define a golden data set, figure out what is most important for your use case. The agent should not mess these outcomes up. And then run an evaluation test suite. I already have that. It's very simple code. Just take the prompt, give it to an agent, get the response back, make an LLM API call, expected outcome versus actual outcome. If it matches, great. Doesn't match, throw an error. Simple. Yeah, we do that, yes. That's up to you. You can add a similarity score, you can add yes, no, 0, 1 for example. You can add whatever you want. So it depends on your evaluation criteria. If you want strict evaluation. That's why we have an LLM as a judge. If it were exactly the same, I'll just use equal to, right? So I have an LLM as a judge because the outcome is also text. This is also text. Maybe the outcome is a bunch of files. Maybe the file names are not the same as I wanted, but they're the similar thing. That's why I have an LLM as a judge. Yeah, you can put in a prompt. So if you look at the LLM as a judge, if you look at the files here, so you look at the evaluation suite, you scroll all the way down, right? So this is the judge output function. So this is what the prompt looks like for the LLM. So you give it a task, an original prompt, expected outcome, agent output is this. And then I tell it, okay, please evaluate how well the agent's output matches the expected outcome on a scale of 0 to 1. So I give it something, perfect match for exceeds expectation, very good. So up to you, decide how you want to do it. All you have is an expected outcome, actual outcome, and then that's it. Easy. Hmm. Correct. Then you have to provide those things to it. So what you will do is, like, you will make the coding agent output a list of file names. Remember the structure output thing I showed you? Make the agent output the list of files. And then you can deterministically in code provide these files to this prompt here. You can like have a template where you paste the content from all the files, for example. Or if you just want to validate the name of the files, that's also fine. Like it creates the right files. Depends on how deep you want to go with it. Exactly. You can feed the contents of the file or the names of the file. For example, you don't want to like pollute the content a lot. It's up to you. But there's a lot of flexibility, a lot of stuff depends on the use case, depends on where you want to add the validation. Should it be at this level? Should it be at the reviewer level, for example? All of these things are part of how it works, right? Reasoning models, yes. O3. O4 Mini is easier, I think. O4 Mini is cheaper and better, in my opinion. I think O4 Mini performs really well for most of my decision-making use cases, to be honest.
But performance-wise, you think there are cases where O4 Mini shines over O3?
Yes. In some coding cases, I've seen it's better. For example, I was building a dependency graph. So by dependency graph, I mean, let's say I have a bunch of actions. So in Composio, you have to test all the actions that we make, right? So when you test these actions, you have to first find dependency. For example, if I have to test one action, I need to find a parent action for this, run that first, and then run this action, correct? So I try to find out what parents there are for a given action. And I do that using O4 Mini. O3 fucks up somehow. O4 Mini is very accurate. It does exactly what it needs to do. So again, it's up to you. You have to experiment, see what works best for you. For me, O4 Mini works great for most cases. Well, I think that's it. End of the workshop. I think a lot of things to go back home and work on. A lot of tasks for you to do. My objective was only to expose you to a world which is more than just hello world for agents. Some more advanced stuff that you will find useful in when you're building your own systems, which we have seen ourselves in Composio on how we build our agents and tools. So I would recommend you to go through all of these. Evaluation is a bit sketchy, because as per outcome is random shit. I made AI generate all of these things, so haha, all the best. मुझे पता था यहाँ तक नहीं पहुँचेंगे. So outcome is fuck all. So like you can, it works, but the outcome is just random things, but it works. So the idea is that go through it yourself, implement everything yourself. Remember the take-home exercises, start implementing them also. See if you can add some stuff to it. Yeah, but that's it. I am done. Yeah, there you go. You had a question?
about this Python.
Pedantic AI. That's also nice. Pedantic AI was, I think, it was the cleanest agent framework that I used because it comes with the structure outputs as default. Like, you don't have all those things.
Do they have traces and all?
I'm not sure. That's why they have a this
platform.
Yeah, fire kind of this one. Fire
Logfire.
Logfire. Yes, I think.
Logfire is
Gets pushed.
so Logfire is equivalent of Datadog, and I'm not sure if they're integrated with Logfire.
उन्होंने कर दिया.
But yeah,
They have
I think
tracing.
they might have the tracing integration.
The Logfire has tracing. So yeah, I mean, like, I used it in the past, but then it was not super mature. So I'm not sure what the current state is.
Okay.
So, but like my idea is that okay, I use it because it has hooks, easy to use, don't have to define multiple nodes. All that is fine, right? I do like for me it's easy to use, has hooks, has everything else. Let's just go with it. If Kinetic AI has similar stuff, you can use that as well. So for me, structure output is important. For me, tracing is important. For me, validation, hooks is important. Ease of use, ease of sharing, all that is super important. So that's if Kinetic AI supports that, I think feel free to go with it as well. So it's all a matter of preference after a point.
Any comments on Langston? Because that's getting a lot of traction.
Langston is nice. Langston is a great tracing platform.
Observability stuff, right?
Observability is great. It has a lot of great things. It has programmatic access. I think it has alerts, everything else also. So I recommend Langston for even higher production use cases. But it's a bit confusing to look at. Like I was using Langston Panic, but now I'm using OpenAI Tracer. Because I prefer that it's a bit less, it's easier to watch.
Give me a moment.
Langston is a bit of a pain to watch. Yeah, I think we'll send some tips on something as later on as an update. Are we going to update the image?
This workshop was in Python. So, like, if I want to build any agent and I'm familiar with most steps, so can I build in Node.js?
You can build whatever library you want. I think like even Composio has a TS SDK, OpenAI has a TS SDK, so you can choose whatever SDK you want. I think Python goes well because I know Python. That's why I do that.
Yeah, I know Node, so like.
Yeah, you can use TS, you can use JS, whatever you want. Any language works. Ultimately, everything is an API call, anyways, right? Everything is a OpenAI API call, so you can choose whatever framework you want.
So, like, I have to refer to AI SDK of OpenAI and then.
Yes. So OpenAI has a JS SDK. You can use that if you want. There's much more to do actually. So it depends on what you're most comfortable with. Whatever language you're most comfortable with, you can choose that SDK to work with. So Composio has TS and Python. I think those two.
ADK and SDK.
ADK also has a Python and also a JS SDK. मतलब उनके सबके SDK होते हैं, like whatever they have in multiple SDKs. I have to be sure. I'm not super clean if ADK supports TS, but I think it does. And if it doesn't do it, it'll do it in a very short time. They are aggressively pushing updates. New versions are coming out, breaking things.
I think we can stop streaming.
Oh yeah.